Hey, welcome back to our video series. We're going to be doing a series of videos now that will help us understand how to use the cell setup and Robocell with our Intelitek ER4 robot, ER4U robot. And we're going to look at about 25 scenarios that I put together over the years that will help us be able to put together the simulator with all of the component pieces that work within that system, and then using that to program it using the Robocell. So let's get right at it. So as you start up the program, you want to go hit File, New, and with that you have this screen that pops up. So as you move the roller ball back and forth, you tilt the factory floor up and down, and then as you hold the right mouse button down, you can zoom and rotate. So those are basically the two controls that you have of the factory floor. So it's going to start putting components together. Now the new object folder is where all the components are held. If you lose it, just remember that your new object one can be gained back just by touching on this particular tab right there. The robot, you only have one choice for the robot. It is the ER4U robot. When you select it and pick OK, you have a choice of whether you want a slide base or not, and for most of these exercises we will not have a slide base. Actually, though, the 1 meter slide base is what we have here in the building, but we typically don't use it for any of these exercises. So when you pick OK, the robot automatically jumps onto the factory floor, and notice that it's suspended out into space. This is the only part that you can't move. If you try grabbing the component, the object drag, it can't move. So that's the only one that you can't move. And then we'll move everything to the robot. Next, we'll want a table. So under the general category, there is a table. The table in itself can have various tabletop colors. I usually tell people to try to stay with the lighter colors if you choose any color at all, so that when you're putting it out there, some of the darker cubes then have a tendency to disappear if you have too dark of a background. And the other thing is that we can change the size. Don't change the size for now, because this is big enough to handle all of the activities that we're going to do here. Probably for the first semester, second semester, we may have to add a few pieces when we look at some equipment that we have to put down. All right, so then pick OK, and then you see the drop arrow go. You can put it anywhere you want on the floor. And then what I do is I use the object drag then to drag it underneath the robot. And I like to center it up on the back side of the table so that I have everything in front that we can grab the cubes from. Now in this first exercise, all we want is one cube. So under the materials category, you'll find cubes. Double snap on that, and you have three choices to make. You can change the color, you can change the material, and change the size. Again, you can choose any colors you want, but when you're putting multiple cubes out there, I suggest that you change and have radical changes between the cubes in terms of their color, because if you try to put 3 red cubes and then stack them, the program doesn't really know that you want it to stack, and sometimes they get lost and kind of collapse on each other. So first of all, and the first one, I never change it. I always show the red one out there. And then also the cube sizes are 40 by 40 by 40 millimeters. Don't change this, because this is the actual size that we really use with the real robot, and these cubes are this size in the real life robot, so don't change those, because we can actually take your simulator program, save it on a jump drive, and then bring it over and actually use it with the real robot. So when you pick OK, then you see the cube where you have the drop arrow. Please, 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 please make sure that you drop it on the tabletop. If you drop it on the floor and on this level, it will stay there, and then it's impossible to put it back up to this level. You end up having to delete the object and then putting a new one out there. So let's say, for example, you do make a mistake. We have our delete object icon up here in the toolbar. You then have an arrow that you place over the part that you want deleted, and then it typically says what you're about to delete. Are you sure you want to do that? And yes, we want to delete cube 1. So that's how you use the delete key. Let's just put this cube back on the table and make sure that, again, that it stays on the table. So now we can grab it and move it around. But usually what we like to do is we want to have a secure placement for that cube. So when we roll over to our RoboCell, that the cube actually is where we say it is in terms of being able to create the program. So I can double snap right on the cube, and I have 3 choices. I can rename it, I can rotate it, and then I can give it a position. So what we're going to do right now is we're going to give it a specific position in front of our robot, and I have it listed in the exercise that cube 1 has an x coordinate of 400, has a y coordinate of 0, and then we'll use our other positions when we get to RoboCell. So right now, though, in the cell setup, you only need 2 coordinates. You need the x and the y, and in this example, it puts it right out in front of the robot. All right, that's it. That's all we're asking for with our first exercise. So I recommend that when we save this, that you save it to the desktop, because we can retrieve it quickly that way. So I want to go to Save As, and then click on the desktop, and then save it as Robot 1, and then hit Save. Now we know where to retrieve it, and we can bring it back very quickly. Now, I recommend that you not close this out. Leave this here just in case there's a mistake, and now we'll go right to the RoboCell. So I already have that set up, ready to go down here, so let me click on that. And this is where we'll actually create the program. RoboCell in itself, we'll do File, and we want to open a new project. So we pick New, and there's a couple of things we have to do before we even get started. One of the things is that we have different choices in complexity for our RoboCell, and since we are professionals here at Barack Obama, I suggest that you use the Pro, and that allows you then all of these choices that you have to be able to program your robot. If I leave it on L1, notice that your choices are rather limited. So anytime that you are working with us here, click on the Pro, because you are a professional robot programmer. Next, let's bring in the picture. So when we're working with the simulator, you want to import that 3D model, and let's go then to the desktop. See all the different folders that I have here. Pick on Robot 1, and then bring that into your system. Now these 2 folders now are linked. So whatever program that we write will automatically move this robot, and it will respond to the program that you write. Under the options category, though, you want to make sure, though, that it's set for the simulator. If we're working with a real robot, we'll actually want to go online to connect with it, and some people, we forget sometimes that it's not, and it moves. So just make sure that you have it on the simulator, otherwise the 2 systems don't connect. Some other things too, in the hardware settings, we'll want to make sure that if we're using any of the peripherals, such as the rotary table or the conveyor belt, that these are connected. And in this particular case, we're not using any of the hardware setup. We don't have any of those items out there, so there won't be anything to do. One of the first things then that I recommend that you do is create a home position for ourselves. We'll go through some of the other toolboxes and the visuals here later on when we get running the robot. But for right now, let's create a position and let's get the robot to move. So when we expand this, then we have the ability to create a position number and then provide the X, Y, Z, the pitch, and the roll. Remember that the blue robot that we have here has 5 degrees of freedom. 5 degrees means that it has 5 axes to rotate. And let me just use the simulator to point them out. Number 1 is the base. Number 2 is the shoulder. Number 3 is the elbow. Number 4 rotates the wrist back and forth. And number 5 spins the end effector or the claw. Now the idea behind this is that you can see that those components are over here. The number 6 component is opening and closing the jaw, which I don't ever really do because it's something that we can use easily enough by having our 2 positions that we can add to the program, or I can manually do them quickly right here by opening and closing those jaws. And you can see the robot responding right now. So when I click open, opens the jaw. When I close it, there's really no need for me to use number 6. So these are our 5 degrees of freedom. And again, number 1 is the base, 2 is the shoulder, 3 is the elbow, number 4 rotates the wrist, and number 5 revolves the end effector or the grip around its axis. So let's go ahead and put a position in here. Our home position in all of my classes, and whenever I've done, I've always used position 99, and the numbers are, these are all in millimeters, 130 for our X, Y is 0, Z is 330, our pitch is -90, and our roll is 0. Why do I pick these numbers? Well, because it fits neatly in a case for the robot, plus these arms then aren't extended out. It's in a nice relaxed position for the robot, and every robot that we have here in the room has a position. Even the Fanuc robot has a position close to position number 99. Now the most important thing is that once you have entered these numbers, that you hit the teach button. Otherwise it will not record. So now we've recorded that position. You'll notice that it now has been recorded under the list, and we're ready to add it to the program. So to add new positions to the program, I usually use this Go Linear one. I really don't have the Go To position. Go Linear forces the robot to go in a straight line, and I like that the best. So let's add position 99 to the list. Now you can either type it in, or you can grab it from the list and put it up. I usually don't change the speed either. We're just in an educational process, so there's really no need to change the speed. So I leave it at 50%, and then I pick OK. And you'll notice then that it has added it to the line of positions that we wanted to go to. And then let's open the grip. So these are usually the two positions that I have all the time with our robot. You can massage the positions a little bit, zoom in and out. we just want to show you now that we're going to put this blue line at the top, and then we have 3 choices of command signals to use to get our robot to move. We can do a single line, which I have to hit each and every time and move it 1 line at a time. I have a single cycle, which it'll move through the entire robot program all at one time. And then we have the continuous run, which will continue to run the program over and over and over and over until you hit the stop button. The stop button's kind of a nice deal so that you can actually stop the robot in any given position and then restart it if you want by where you put the blue line. But these are the 3. You can also find them under the Run menu. Single line, single cycle, and continuous, or even quicker yet, if you hit the F keys, F6, 7, and 8 correspond to the same 3 commands, and then F9 is your stop button. So let's go ahead and put the blue line at the top. Let's do it at a single cycle, and you'll see the robot then move to that home position, and it has opened up the grip. Now, we want to add a series of positions that we need to record. And to do this, then, I will hand out a nice handout sheet that you can follow along or that you can use, that you'll see these positions ahead of time and have those placed with you. And then you can add those to the position at the bottom. Also, then, I've given you the handout so that you can actually put in the appropriate positions where they go. So everything should be easy enough to do, but the trick is to be able to add it to the program. So we want to be able to move this cube from this position, and we want to move it over here onto the side, which then is, this happens to be 400, 0, 400 for the X and 0 for the Y, and we want to switch that now, in which we now have the robot moving the cube from a 0x to a positive 400 and putting it on the table. So we want to hover over the cube, which we'll call position number 11. We want to grab the cube, which we'll call position 1. We'll bring it over here to the side, which we'll call position 12, and then down here at the table, which we'll call position 2. Now, the book tells us that we should always have all of our single digits with the cubes at the table, and then this corresponding position over the top. So if this is position 1, then we should have position 11 over the top. If we're using position 2, then we should have 12. If we have a position 3, we should have a position 13, and so forth. So I usually don't do it that way. I mean, I just go ahead and start adding positions 1, 2, 3, 4, 5, but we'll do the first one as the book says. So the next thing then is to go back here and expand our teaching position so that we can put those positions in. So let's do the position for position number 1, and according to the information that I provided you, position number 1 is 400, 0. If this is at the table, any position with a cube at the table is 17.5, so that the middle of the claw or the end effector, or what they call the TCP, tool center point, grabs this cube right in the middle, and since this cube is 40 millimeters from top to bottom, about 17.5 puts it right there in the center, and we'll continue to use that 17.5 on all cubes that are sitting on the table. So once we have that, now we'll leave the pitch at -90, which means then that the arm will come straight down, and then we're reaching out, so there's no need to have the end effector rotated, so we'll leave that alone. So now hit the teach button. So let's teach now position 11, which is over the top of that. Now the reason I do it in this order is because X will be the same, Y will be the same. The only one that you have to change then here is our Z, which would be then 200. So we're going to use 200 millimeters above the table in order to hover over each one of our cubes. Let's create position 2. So now we'll reverse these. So now we have this X, this 400. Remember that the 2 is at the table, so we'll change this to 17.5. Our pitch and roll remain the same. Again, the most important thing is to hit the teach button as you change positions. And position number 12. Now since I have these numbers all the same, the only thing I have to do then is change to the 200. Alright, so let's go add these. And how would we do the program? Well, first of all, we have the grip open. So now we want to hover over the cube, and according to the diagram that I have provided you, that position then will be position number 11. So let's add 11 to the list. Now you'll notice then that this is a way of double checking whether you got stuff done correctly or not. We recorded a position 1, 2, 11, and 12 along with our 99. So let's add position number 1 to the list. Position 11 is where we want to go, over the top of it. So let's just do a single line now, and let's see where position 11 will take us. Beautiful, we're right over the cube. So position 1 then will take us down to the cube. Let's do a single line, put the blue line over the top of that, hit the single line. Now it reaches right down over the cube. So now I've got to grab the cube. So remember that at this point, you have to close the grip. And again, let's keep walking through individual commands so we watch it happen. So there the grip is closed. Now I recommend that you go back above the cube, so come back out of the cell the way you came in it. I always talk to students that there are always people working in and around the robot. We may have machinery. Just because we're on a simulator, we want to think about the big picture, and that when we look at real life scenarios with this thing, we always want to make sure that we kind of practice safety whenever we're doing this. So I recommend that we go back to position 11, which would then take it straight up out of our cell. Let's watch that happen. And now we're above the machinery, we're above people's heads, we're above the cages that we want to, just avoid. So now let's move ourselves to the new position. Let's add position 12. Let's check that then with a single line command. That should take us to our new position. Sweet. Position 2 takes us to allow us to put it on the table. Position 2, single line. Alright, that's working good. Now you want to make sure that you open the grip because you want to leave it there. So let's force that grip open and watch it happen. Single line, there it is. Remember that if you use these manual motion down here at the bottom, you will get the robot to do what you want it to do, but it does not record. So even though that I might open the grip at this particular point or close the grip, remember these are just manual movements and they will not, I repeat, will not record on the line. So you actually have to make sure that you place these in here. Again, thinking about our safety factor, let's get up out of the cell the way we got in it. Let's go back to position 12. Let's run a single line. And now since our job is done, we can return to home. Let's return to the home position. And then good housekeeping says let's just close the grip and we'll be done. So let's watch it work then. So let's do a single cycle so it'll run both commands at the same time. And there you have it. We've completed the task. Well, let's watch it in its entirety. Up here in the left-hand corner of that box will allow us to reset that cell from the beginning. I click on that. Let's zoom in here to watch it. Let's put the blue line at the top and let's run the single cycle and make sure that we've successfully completed robot number 1. All right, there you have it. So this is robot number 1. This is the first opportunity that you've had to use the cell setup and to use the Robocell in order to not only teach the robot its given positions, but also then added the program to it in order to create it. Now to keep this then, I recommend that you do File, Save As, and then this happens to be all of the canned programs that Intelitek gives you with this. I typically try not to save anything in this project area because it just adds to the confusion of trying to find it. So I recommend to students to either save it to a jump drive or save it to the desktop, and then robot number 1 is what you'd want to save it to, and then we'd be good to go. So that's it for today, and we'll move on to robot number 2. Welcome to our video series on the Intelitek ER4U robot. This is robot number 2, and so then we'll open up Cell Setup and create a scenario that we can use or import into our Robocell. Robot number 2 now consists of a robot, a table, this time 2 cubes. We're going to put a blue and a red cube out there on the table, save it to our desktop then as robot number 2, and then open up Robocell and create a series of positions then that will move both the red cube and the blue cube to new positions. We'll still follow similar rules that the book tells us to do, in that positions number 1, 2, 3, and 4 will be on the table, and then the corresponding positions over the top of that. 1 will be associated with position 11, 2 will be with 12, 3 will be with 13, and 4 will be with 14 as we create our program. First thing we want to do though is create the simulator. To do that by using our cell setup, so we want to go File, New, and there again we have the factory floor. As I use my roller ball, I can roll it back and forth. As I push my right mouse button down, I can zoom in and out and then rotate the floor. First thing you want to do, remember that the new object folder typically comes off when you start a new program. If you happen to lose it by some sort or reason, it can be found directly under this new object. So re-click that and then it brings back that folder. So the first thing we want to do is grab the robot, no slide base, pick OK, and then the robot automatically puts itself up out in the middle of space. Don't panic. I mean, that's just what it does. As we said in our first video, the robot is the only thing that we can't move. Stays stationary. We could, I guess, if we wanted to, we could rotate and change its position, but there's no need to do that. The robot stays at the 0 and 0 position, 0x, 0y, and 0 on our Z position. This is the position then that all of our coordinates are based from, and this would be our home position for the robot itself at 0, 0, and 0. So it's kind of a big deal that we keep it there. Next, under the general, we want to put a table. Remember that you can change the color top of the table. I recommend that you keep it to the lighter colors, as if we try to go too dark, sometimes on the darker cubes we lose their position. So let's use this green today. Keep the table size the same. There's no need to change that for these first few exercises. So then when I pick OK, I then can place it anywhere on the factory floor. By using my object drag command, I can drag it underneath the robot. And I like to keep it towards the back, centered up under the table. So it gives us all of this other real estate out here to be able to put our cubes. Today we'll be using 2 cubes. Under material, under the cubes category, today we want to bring a red and a blue cube. So you have 3 choices. You have the color, you have the material, and then the size. Don't change the size. Can I say that again? Do not change the size. The 40 millimeter by 40 by 40 is the actual cubes that we have that we use with the real robot, so it's necessary that we change that. You can change the material if you like. I typically don't. It's really no need. But we do then ask you sometimes to get some specific colors out there. Now, by giving colors, make sure that you use, when you're putting colors out there, that you use drastically different colors. If you try to put 2 red cubes on top of one another, or 2 blue cubes on top of one another, they have a tendency to fall together. And when you start working with the Robocell, even though you have 2 cubes out there, they've kind of dropped in on one another. It's a cheaper program, but it still works very well. So I want to put my red cube out there. Let's go ahead and grab the blue one. I'll use this blue. Make sure that you put both of the cubes on the table. And now let's go back and reposition. So by double snapping here on the red, I want that position to be, and we have it on the handout I've given you as X is 400 and the Y is 0. I think we've used this one, the last one. It should put it right out in front of the robot. That's our red cube. Our blue cube then is set up to be 250, negative 250. Okay, so that would put it out just to the left of the robot. So any of the negative Y's places it to the left of the robot. Any positive Y's places out to the right side of the robot. All right, that's it for this exercise. This is all we need. We can close, pick OK. We can close this up. Save the robot now. I recommend that you save it to the desktop. And in this particular case, save it as robot number 2. Save. Now by saving it to the desktop, We can quickly access it if there's things that we need to do with it. I also recommend that you not close out the program, because if there's an error that we need to go back and check, we can quickly look at this setup, resave it very fast, and then re-import it into our Robocell. All right, so let's go ahead and open Robocell and start off then by creating a new project. Couple things that we need to do every single time we do this. Remember that we are professionals. So you want to pick the Professional tab, and that allows us to not only get access to more commands, but it also allows us to be able to expand this instead of the simple one. If I leave it on L1, I don't have the ability to expand this or to be able to add my program coordinates. So with the Professional, I get a chance to do that. We want to import that picture now, so let's import the 3D model. On the desktop, let's find robot number 2 and then input that. And then I always recommend that you downsize it so that you keep it onto the one side. You can zoom in using the same controls we did before, pressing the right mouse button down to zoom in and rotate. Then you can use the hand to drag it around and center it up on the screen so that you have a good opportunity to see the robot. Whoops. A good opportunity to see the robot. I don't know where it went. Let's try that again. Good opportunity to see the robot. Yeah, if you lose it, just go get it again. It's not a big deal. I always like to zoom in a little closer so I know that what I'm watching. And I can see what's going on. All right. So now, shucks. All right, not going to work hard just yet. First thing I want to do is create that home position. Each and every time we're calling that out as position 99. The numbers that you should register in your brain, and we have it listed all the time as our home position, is position X is 130, Y is 0, Z is 330, our pitch is -90, and our roll is 0. Teach. That'll be the first thing that we do every time. Blue line at the top. Let's go get position 99. Let's open the grip. This is the same every time. We'll use position 99 as our home position. Put the blue line at the top, run a single cycle. And there it goes into our nice relaxed position, and we open the grip. We'll start from this position and then end from this position. So let's just go through a couple of things. As we did before, up here at the top under the toolbar, you have the single line run. This one will then, you'll have to click through every single line. As I click through it, each one of them has to be done individually. We have a single cycle that will run through immediately through all of them by itself. And then we have the continuous run, which then continues to run over and over and over and over and over again until you stop the robot. Here's our stop button. That stops the robot completely and wherever it is on the line. Also underneath the run menu, this is the toolbar and this is the menu. We have those same controls you can use: single line, single cycle, run continuous. We also then have the F6, 7 and 8, and F9 if you like the keyboard kind of thing, that you can do things instantaneously. So you have 3 different ways of actually running this robot. So now let's go down to the bottom and record these positions. given you a handout with all the positions. You just need to type them in based on the information I provided you. Position 1 is where our red cube is resting. Let's call out that position 400, 0, 17.5 at the table. Our pitch is negative 90 and 0. Hit teach. Let's teach position 11, which is right over the top of 1. So all you need to do is change the Z is to 200 and teach. Position 2. Position 2 is 250. This is where the blue cube is sitting. 250, negative 250. Does make a difference whether you put negative. You don't need to do positive, but you do have to put negative. And then position 2 is at the table, 17.5. Leave your pitch alone and roll alone, and then hit teach. The most important button in the whole thing is the teach every time you change a number. Let's go to position 12, which now is over position 2. These remain the same except for this, 250 or 200, and then hit teach. Let's do position 3. Now this would be the new position, most likely then for our red cube. $250, positive 250. And since it's a 3, it's at 17.5, and then hit teach. Position 13 is above that. Change only the Z and teach. And then position 4 will be 0, 400, and since it's a 4, we'll put it at 17.5. Hit teach, and position 14 will be the 200. Okay, so I misspoke. So we're going to have, actually position 3, we are going to have that blue cube move to position 3, and then position 13, and then for our red cube, we have 1, 2, 14, and 4 associated with that. So again, the blue cube is 2, 12, 13, and 3. The red cube is position 1, 11, 14, and 4. So now to double check our positions that we have saved in here, notice that they're all listed here along with position 99. We've already have that up there. So it's a matter of which cube do you want to move first onto this list. So let's go ahead and move our red cube. And according to my diagram, we have 1, 11, 14, and 4 connected with that. So the first thing we want to do, let's put the blue line down here to number 1, and I should say line number 3, and we want to move to the red cube. So to get over the top of the red cube, we call out position 11. If we run a single line, it should go out in that direction, and indeed it does. Let's go to position 1, which is at the table. Run the single line, There you have it. Now we want to be able to move the cube, so really, really important. Let's close the grip and watch that happen. Now we could move it to the new position. I always recommend that you come in and out of the cell straight up and down for safety reasons. Always keep safety in your head when moving with robots. So we'll want to move now back to position 11. You can either type it in or grab it off the list. Let's just watch 11 happen. That should go straight back up. And now, according to the handout, we want to move to position 14. Let's have it get over there. 14 then should move to there. Our position 4 then would be at the table. Let's watch that happen with a single line command. Alright, so we want to leave it there. The only way we can leave it there then is to open the grip. Let's have that happen. Watch that. Got to move in and up away from the cube so we don't disturb its position. Easiest way to do that is to go straight up. So position 14 is associated with that. Single line, let's have it move up. And now we can go get the blue cube and set it to its new position. Our blue cube numbers are position 2, 12, 13, and 3. So if the blue cube is number 2, then we want to be moved to position 12, which would be then the one that would hover over the top of that. Let's do single line and watch that occur. Robot moves. Reaches out. Now, one thing that we really should do here, though, is either rotate the cube to a 45-degree angle or rotate our grip to a 45-degree angle, because at this point it's going to grab it on the corners, and we'd rather not have it grab on the corners. We'd rather have it grab on the flat surfaces. So let's just go ahead and revisit position number 2. We can do that by getting the number, putting it in the box, and then say get position. So at this point then, let's move it to a -45, and that'll actually move the claw, and you'll see it rotate before it picks it up so that we can grab it on the flat sides rather than the corners. So you usually have two choices. You can either rotate the cube when you put it down, and that's easy enough to do, or we can write the program to be 45 degrees. And that, to do that again, is that we have the numbers listed, we get the position, here's a position for number 2, we can readapt those and change any numbers. I'll go with the -45, and now I'll put teach. So that's the first time we've had to change a number. This is how you do it. So let's add position 2 to the list, to our program list. Let's watch it, and you'll see then the grip change position to be able to grab it on the flat side. Now if you put +45, it would grab it on the other side, on the versus it would grab it on the flat sides going on the 90 degrees. It doesn't matter whether you add the negative or the positive. Be sure to close the grip at this point. We want the grip closed. Let's watch that happen. And now let's remember to go back to position 12. We always want to think safety about our cubes in the robotic cell. Go back to its position. Now we wanted to move it to position 13 and 3. Let's add those to the list. Let's move 13. Let's show you that on a single line. Now here it doesn't matter how we put it down. We'll leave it, put it down. If we wanted to rotate it back again, let's go get position 3, get the numbers, our roll, -45, and teach. This is how we change the numbers. Let's add number 3 to the list. And then let's watch it happen. And it straightens our cube out. Again, the most important piece though is that you can get any position that you want and then hit get position, and then it gives you those numbers of where it's sitting right now. You can change those numbers, but it's so important to hit the teach button. All right, so let's move back to position 13. Always think about safety within the cell, straight up and straight down. Watch that single line. And there again, what did I forget to do? Well, remember that you got to open the grip. The cube's not going to stay there if you don't open the grip. Let's go back to 3. Now I can put the blue line right here over 13 and it will insert itself. It inserts automatically. And now let's open the grip and move then to position 13. We're all done for this exercise. Always like to have the robot go back to the home position. It's always a nice, good housekeeping thing. Let's move back to position 99, and then let's close the grip. Let's watch that happen. And that allows us then, when we turn off the robot, that we can put the bag over the top, and it just looks a lot nicer when we do that. Okay, so up here in the corner, upper left-hand corner of this image, 3D image, is our reset the cell. Let's put the blue line at the top and run a single cycle this time rather than a single line to see if it indeed is going to go. This is what I recommend if you're in class, that you allow me to watch your program work before you print and turn it in. That way I know you've done the work and your neighbor hasn't done the work and all you did was put your name on it. So, and we'll show you how to do that here in a minute. So let's run a single cycle from the top, blue line at number 1, and let's watch it work through. All right, there you have it. Let's ring the bell, do the happy dance. Robot has been successful. Now the last thing then I want you to do is be able to put your name on the program. And to do that, we're going to go over here to the program flow. When I touch on it though, you're going to lose your image. That's okay at this point. And we want you to put a remark. The remark is the RE program position, and then under the text, then just put your name. I kind of like them in all caps, so set your cap locks down. And there you can put it, and then print it. It's necessary, though, that you put the blue line at the top, file, print. If the blue line's not at the top, this one won't be highlighted, so that you won't be able to do that. As you select it, then, here at the school I'm at right now, then you must pick the printer. Printer then shows up, and then hit OK, and it will send it to the printer. So that's all you need. This ends our robot number 2. If you're looking to save it, make sure that you put project save as. Don't save it into the project file for the program here. It just continues to pile up as you do. Save it to either your jump drive, which I have here, I have one connected, or save it to the desktop. The only problem with saving it to the desktop, though, here at this school is that at night, at midnight, the school district goes through and eliminates all the other files that are here, so you won't have this in the morning. So make sure that wherever you're saving it as, you know that you can retrieve the file, save it, and there you have it. Well, this concludes robot number 2. Stay tuned for robot number 3. Back to our video series. Welcome back to our video series on the Intelitek ER4U robot. This is robot number 3. We're now going to look at using some cylinders, and we're going to place them out on the table, and then we're going to stack those cylinders on top of one another. So let's get started. Our cell setup then is all of the component pieces that we need in order to create our simulator setup. So let's go to New. Again, here is our factory floor. By rotating the roller ball back and forth, we can tip the floor. By holding the right mouse button down, I can zoom and rotate. First thing we want to do is put the robot out there. This is the new object folder. These are the component pieces that we can add to the factory floor. If for some reason it disappears, it's located right here underneath this icon. So click it back and you get the list back in again. There's only one choice for a robot. We don't use slide base, so leave that as no slide base. Once you hit OK, it automatically puts the robot out on our factory floor. Let's put a table underneath that. Under General, there is a table. This is the table that we use. You can change the color of the tabletop. I always recommend that you try using the lighter colors for it. Let's use a light blue today. Don't change the size. There's no need to change the size right now. It's large enough for us to do anything that we need. Place it anywhere on the showroom floor, and then use the hand to rotate it, or I should say, to pull it underneath the robot. I like to put it as you see it here, with the robot to the back centered, so that we have all of this room, all this real estate here to be able to place our materials. Under the materials, today we're going to use cylinders. We're going to use 4 colors. So we want red, green, blue, and yellow. So let's place our red, green. Let's use, that's kind of a forest green. Let's put that out there. Let's do blue. blue. I like that one right there. And the last color then is yellow. Always try to use, whenever we're stacking, use 4 or 5, or make sure that every one is a distinct color, because if you try to stack 2 cubes of the same color, this program isn't really designed for that, so they might get lost with one another. So by using as different colors as possible, then we can stack them real nice. Each one of these has a position. On the handout I've given you, double snap, go get the position for each one of those. Our number 1, which is red, is sitting at 300, negative 200. Our green cube is at 300, negative 100. Our blue cube is sitting at 300, 0. And our yellow cube is sitting at 300, 100. All right. So all there is necessary for this one. Make sure when you're saving, I recommend you save it to the desktop so that's easily achieved or retrieved. Robot number 3, and then hit save. Also, I recommend that you not close out this program, so in case there is a problem, that we can instantly go and retrieve it, check it out, and then resave it. But that's all there's necessary for robot number 3. So let's go get Robocell and begin to program. Robocell, file new, and let's go get the 3D picture. Let's import it. Import it from the desktop. Robot number 3, and then let's move it over here to the other side. Zoom in if you like. I always like to zoom in because it's a little easier for me to see things. Again, one thing that we didn't mention as we started this series, under the options category, it should come up under simulator all the time. Just make sure that that's done. The online would be, if you're using the real robot, you'd want to make sure that you've selected the online. At this particular case, we're going to use this, and since we are professional robot programmers, you always want to pick Pro. That allows us to expand our teaching box to teach the positions that we want. Otherwise, you can't do that if you don't click on Pro. Always, 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 the first thing we're going to do is create the home position, and our home position is position number 99. The numbers for that: 1300330. Please put this to memory, negative 90, and hit teach. Use the go linear command to add that to our program, position 99. Open the grep. These are the first 2 moves that we do all the time, and then you can run a single cycle and then watch that occur. Where do you find these? In the Robocell toolbar. You'll have a single line, single cycle, and continuous run. Continuous run will continue this thing over and over and over and over and over. By putting the blue line at the top, you get that response. Also, under the run menu, you'll find those same commands: single, single cycle, continuous, or if so, I guess I don't have never used these with the F6, 7, and 8, and 9 corresponding to those, and the F9 being the stop button. All right, so we are going to take now, and the idea of this exercise is to take the 4 cylinders, and we're going to stack the green, the blue, and the yellow onto our red cube. So we're looking to position these all up on top of that one. So let's start by adding our program and inputting our positions. Now, according to the diagram that I've given you, our positions are listed with our individual cubes. Now, I've gotten away from the style of using position 1 and 12. I'm sorry, 1 and 11, 2, 12, 3, 13, 3, 14, because it's just easy enough to be able to record each one of these positions. So for our red cube, if we needed to use that red cube, we're going to head then and add our position number 1. So position number 1 for our red cube then would be 300, negative 200, Z would be 17.5, negative 90, 0, and then hit teach. Now, I'd kind of like to do positions 1 through 4 right away, because then I can get these 4 out of the way, and since they're all in the same position, one of the things that I want you to realize that is when I place a cylinder on top of this, remember that the distance from the top of the bottom of the cylinder is 40 millimeters. So we can use that then so that when we take our 17.5, we can add the 40 millimeters to that and end up with 57.5. So in position 2, all I have to do is change the Z to 57.5. Our third cube, let's add 40 to this. Third position then, position number 3 would be add the 40. So now we have 97.5. And position 4, add 40 to the 97.5, which would then be 137.5. So we just programmed the first 4 positions. In this scenario, we'll never use position 1 because we want the red cube to stay right there it is. But just in case we had an idea where we wanted to move it, we could. Now, position number 5 then is going to be placed up over the stack, so we always want to be able to move in and out of our work cell. And we're going to call that position number 5, and we just need to be above 137 millimeters. So let's just use 200 during our moving up in and around the cell. So we'll say 200 millimeters is high enough to move away from all of our positions. So now you see that we have 1 through 5 recorded. So now we want to move over and pick up our initial cubes, or I should say cylinders. Positions 6 and 9 are going to be associated with the same number. Positions 7 and 10, and position 8 and 11. When you look at the diagram I've handed you, you'll see that those are the numbers that we're going to use. So let's create those. So position number 9, I'll start there. This then is 300, negative 100, which is the position right now where our green cube is. Since this is the position at the table, it's going to be 17.5. And we'll leave these numbers the same. Since it's a cube, we really don't have any sharp edges to grab. So we'll pick OK. Position 6 is associated with that according to the diagram. So all we need to do then is change the 200. 7 and 10 are associated. 10 will be 300. The blue cube then was at 0. And since it's at the table, 17.5 and teach. 7 is associated with that. 7 is at the 200 and then teach. So you can see then that as I look at the list, they're all beginning to add up in there. And position 11, that is our yellow cube. Our yellow cube was at 300, 100. Since it's at the table, 17.5, hit teach. And now the position over the top of that is 8. And we'll change this to 200. And then teach. Okay, so these are all the positions that we need. So let's start adding to our list. And we want to move our green cube first. We want to move our green cube onto the red one. Now the red one, remember, is sitting at 17.5. We call that out position 1. So we want to move that to position 2. So looking at my diagram, I'm going to want to go from my home position to position 6 to 9. We'll want to close the grip. Back to 6 to 5 and then to 2. So let's see if that works. So again, safety reasons, we always want to go in and out the cell. If I look at the page that I've handed you, 6 and 9 go together. So let's put the blue line here at number 3. So the first place we want to move is position 6. So let's run a single cycle and let's just make sure then that under the single line, that's where we went. And indeed we do. So number 9 is picking that up at that position because those two are associated to one another. Let's use a single line. There it is. All right, so what do we got to do? Got to be able to grab the cube so we can move it so it's a closed grip. Watch it do that. All right. So which numbers do we have to go to? So we are going to go back to 6 to 5 to 2. So 6 to 5 to 2. And let's make that work. So we've closed the grip already. So let's go single cycle now with those 3. So it should pick it up. Moves it over the stack. Position 2 now is on the red cube, or on the red cylinder. And there you have it. So let's go back and now get the blue cube. So the blue cube is over here. So we make sure we leave it. Remember to open the grip. So now, what are our numbers? 5, 7, and 10. So it's always important, safety reasons, we always want to go straight up out of the cell. If we try to go right to the blue cube, we'll knock the green one off the list, we'll off the top, so we don't want to do that. So let's go to 5. To 7. Now 7 is over the top of 10. Now again, you can put the numbers directly in there or you can choose them from the list. Let's go to number 10. You can see I can do it both ways. So let's make that happen. So let's do a single cycle for those 3. Booyah. Remember to close the grip. Let's force that. Let's watch it happen. Single line. All right, so here's our list then. So we're at 10. We want to go back to 7. We're just backtracking ourselves. So 7 to 5, now to position 3. And that's where the blue cube then would be on top here. So out to 7. Retracing our steps. To 5. We'll use position 5 a lot. And now, since it's the 3rd cube, let's put it at position 3. And let's watch this happen. So we've got the grip closed, so let's do single cycle now, 7, 5, 3. Let's watch that happen. So there's 7, 5, and we did 3 at the beginning. Okay, there you go. Let's open that grip. Let's leave it there. So do a single line. So now how do we get the yellow cube? Well, again, back to 5, which gets us up out the top. As I look at my drawing, 8 and 11. So back to 5. Otherwise, we'll knock the cube off or the cylinder off that stack. So let's get up over the top of it. So let's leave it there. And now let's go get the yellow cube. So we have position 8. Position 11. Remember now that we're going to want to close the grip. Let's just watch that happen though. Run a single cycle to this point. So 8. Position 11. Here's right at the cube. Remember to close the grip. Close the grip. All right, let's go back. Let's put it on the stack. So the yellow cube or yellow cylinder is at the top now. So we've created that as position 4. So how do we get there? Let's backtrack 8. That should pick it up. And here we go. Back to 5. We use that one a lot. Let's have that one do a single. Let's put it down. The yellow cylinder is at position number 4. Let's go get number 4. Put it down at 4. There we have it. So how do we finish out? Well, make sure that you open the grip. And again, since we're all complete, we certainly want to go back to the home position. If we do that right now, though, we'll knock that yellow one off the top. So let's get up and watch that open the grip. Let's go back to 5. There's 5. Let's do a single line. All right, so now we're safe. We're up out of the cell. Go to position 99. And then close the grip. I always like to watch these work singular so I don't, if I'm making a mistake, I catch it right away. And there you have it. So, just to make sure though that we can do this through the whole process, up here in the 3D image, when you hit this little box up here in the left-hand corner, that'll reset the whole cell. Let me just massage this a little bit so we can visually get in here and see what's going on. That looks good. Okay. So let's put the blue line at the top and run a single cycle one time through, and then let's see what happens. Well, there you have it. Let's ring the bell. So it worked out perfectly. The last thing I want you to do then is to be able to put your name on the program. And to do that, we're going to use the remark command. When you hit the program flow, you'll lose your image. That's okay, because we're all done with it already. Use the RE line, which is a remark. Anytime you add a remark to the line, to the program line, it does not change the program at all. The robot doesn't see it. It's just there for clarification. So put your name. I kind of like them in all caps, so I better do that then. It just looks nicer. And then we'll want you to print the drawing. To be able to print the drawing, remember, put the blue line at the top. Under File, you now have this darkened in so that you can actually pick on it. The program, to be able to print the program, choose the printer that you want to use, and then just hit OK, and it sends it off to the printer. And then what you'll do is you'll end up getting the program, and that's all that it prints. And that's really all we want to document that you actually created the robot program. So there you have it. That's robot number 3. Stick around, folks, because we're going to do robot number 4. Hey, welcome to our robot series. This is the Intelitek ER4U robot. And this is robot number 4. In which case we are going to start with two cylinders now that are stacked, and then we're going to unstack them. So the trick is here when we're doing the cell setup is that we're able to stack the cubes. We'll stack a red and a blue, not cubes but cylinders. I keep saying cubes. And then we'll unstack them. So it's a matter of looks like we have 1, 2, 3, 4, 5, 6, 7 positions we have to teach. And then we'll go to our Robocell, then add the simulator, and then we'll start from there. So here's robot number 4. Let's go ahead and open up a new folder. Again, remember the factory floor. As I use the roller ball, I move it back and forth. As I push down my right mouse button, I can zoom in and rotate. If you lose the new object folder, it's right here listed. Click on that and it opens back up. Let's put the robot out there. There's only one robot to choose from. No slide base, and when you pick OK, it automatically throws it out there for you. Don't panic that it's out in the middle of space. It's just a cheaper program. Still works. Let's slide a table underneath that. You'll find the table under General. two things we can do with the table. We can change the tabletop cover. I always suggest that we do lighter colors. Let's do an orange today. And then leave this table size. This, don't change the size. Let's put it anywhere on the table then. And then you can use your drag object then to pull it there. I always put it to the back center so that we have all this real estate up front to be able to put our other objects. Today we're going to use a red and a blue cylinder. Let's use under material. Let's grab the cylinder. We have a couple of choices with the cylinders. We can either lay it down horizontally or vertically. We'll leave it vertical. Here's our red, which defaults it. You can change the materials of the object. I typically don't. And then you want to leave this, because this is what it is in real life. Their diameter of 40 millimeters and the height is 40. Leave those. When you pick OK now, be sure that you mount it on the table. And I recommend place it, this one, go right away and place this immediately by double snapping on it. You can get the position, and we're asking you to put that position then at 0, 400. And that'll place it to the right of the robot because that Y was a positive number. Let's grab the blue one, leave that all the same. Now this is so very important that you zoom in and you place the arrow right on top and then you click OK. That way you can stack it. Once you place it on the table, you cannot pick it up again to place it onto the cube. You must put it on the cube right away, and it's going to be very close to the position that you want. 0 and 400. And that gets us ready to begin the first exercise. So that's all we need to do with this one. This concludes our cell setup for robot number 4. I recommend then that you save it to the desktop, save as. That allows us to have easy access. Robot number 4. And then hit save. Also a good idea to leave your cell setup open in case there is a mistake that we have to go back and look at it again. So you can open up the RoboCell immediately and then import that file. So we want to start a new program, so File New. Couple things you have to do here though before you get started. Remember that we are professionals and pick the Pro. By picking Pro, that allows us to access of more options in our workspace, as well that it allows us to open up the teaching position so it can be expanded. One of the first things that I recommend is getting ourselves into the home position. Let's get our robot simulator in here so that we can see it work. Let's import the 3D image, go to the desktop, and at the bottom of the list you'll have number 4. Let's grab that number 4. I always like to place it on this side because I don't spend, in these earlier exercises, I don't spend a lot of time in the program flow area, so I can get that to do what it needs to. Now I can see once I create my home position, our home position is position 99. And again, each exercise I hand you, you should remember, and position 99 is listed at the bottom of the page where we have our robot programming handout. X is 130, Y is 0, Z is 330, our pitch is -90, and the roll is 0. hit the teach button. Go up to our program, add position 99, and open the grip right away. Blue line at the top, let's run a single cycle. And you should see the robot move in our simulator and open up the grip. Again, let's just go back over some things. In the toolbar, you have single line, single cycle, and continuous that you could get the robot to move. In the run menu, you have those same single line, single cycle, continuous, and the third way to get it is with the F keys, F6, 7, and 8, and our stop button is F9, or you can hit the big red stop button right there up in the corner. The other way to do that. All right, so let's get down here and now teach positions. So in the diagram that I provided you, we have position 6 and 7 listed over here where the robot has its cubes. The red, I keep saying cubes, the cylinder, the red cylinder is position number 7. So let's record that then. So add 7, and it is at 0. Y is 400. Z is 17.5. And the roll and the pitch will remain the same throughout the entire exercise. So hit teach. Position 6 is the blue cube, according to the diagram. So position 6 is all of the same numbers, except then that, remember that each one of these parts is 40 millimeters in size, so add 40 millimeters to the 17.5 and you end up with 57.5, and then hit teach. So on the diagram and on our listing, we have 6 and 7 listed. So let's go ahead and do the rest. So we're going to move these. So as we unstack here, we're going to call that one up at the top position 16. And that has all the same numbers as our stack right now, except for, let's go back to that Z200, which is 200 millimeters off the table. We're saying that that's high enough to be associated with it. So our blue cube is associated with position 2 and 12. So let's put those numbers in here. Position 2 is 300, negative 150, and looks like it's at the table, so it's a 17.5. Remaining pitch and roll, hit teach. Position 12 is immediately above that. The only thing that needs to change is the 200. Teach. All right, so let's do the red cube. The red cube is going to be moved to position 11. $250. Negative 50. And this is above the table. Kind of staying with some of the standard coordinates that we put in before, with position 1 and 11 and position 2 and 12 being associated. So let's do position 1, 250, negative 50, 17.5, and teach. Okay. So we've them all listed. So let's just add them to the program. And let's move these cylinders. So the blue one is to move first because it's the one at the top. Our gripper is already open. So let's go get the blue cube and let's move it. So the blue, over the blue is position 12. So let's get number 12 according to our diagram. Let's see if that works. So a single line. Whoa, that's not where it is. I bet you I forgot to put the negative, so here's a good chance. Let's go ahead and look at position 12 and see what we did. 12. Let's get the numbers. So it's position 6 where we want it to go. So 6 and 16 are associated with each other. So 12 is not where we want to go right now. So we can just double snap on that and we can easily change those numbers. So that's not where we want to be. We want to be to 16. So it's no reason to erase this. You could just go ahead and put, now it'll switch itself to 16. Now let's see if that works. So single line, let's see where it goes now. Well, look at that. It went where we wanted to go. Now we could have just cut it. If you select that line and then you right click on it, you get a number of lines that you can use. You can find, add a remark. These are quick commands. If you select cut, it'll erase that. So there was no reason to cut it. If I just double click on it, then I get the series of numbers that I can just change and then re-add the number, and then it automatically switches. So if you want to take it out, right click on it and cut. You can also put the blue line on there and hit the delete button. It'll do the same thing. So now let's go get the blue cube, and that was position 6. I usually just use the go linear. So position 6 then, so it was a single line, and that was over the top. Remember, if you don't close the grip, that cube's not going anywhere. And again, as I said before, we always want to go straight up and down. So let's add our position 16. Let's do that single line up and over. All right, so look at the diagram. It's saying that the blue cube is going to position 12 and then 2. So let's add 12. 12 puts it above the table. Position 2 puts it at the table. Let's do those two. Let's run single cycle now. Well, there it is. Sweet. All right, we got to leave it there. We can't leave it there if we don't open the grip. Open the grip. Now, if we try to take off right now and grab the red cube, we'll bang into the blue one. So we want to get back up over the top. So over the top of that one was our position 12. So let's back it out. Get back to 12. Run a single line. Yep. Oh, that's a beauty. Now let's go get the red cube. So to get over the top, we said that we want to move to 16, gets us over the top of that stack. Let's see if that work. One at a time, that should get over the red cube. Our red cube is position number 7. Let's add 7 to the list. Always go linear. If you use any other choices, then the robot will try to take its own pathway there, which is not always maybe such a good idea. The robot is definitely not as smart as you are. All right, close the grip. We're not going anywhere if you don't close the grip. And now we can take it to the new position. Again, safety first, always try to go in and out of the cell, straight up and down. Gives you a lot more accuracy too, because you're really only changing one number, and that would be the Z position. Now the blue one, nope, red. 11 and 1. So let's go to 11, to the 1. Let's watch that happen. 11 and 1. That should be 250, negative 50. There you have it. Make sure we leave it there. We want to open the grip. Let's watch that happen. Single line. Oop, what did I do? I put close grip. All right, right click and cut. There we go, open grip. Yeah, it looks better. Safety first, in and out of the cell. Let's go back to position 11. See that move up? And then we can go home. Our home position is number 99. I always recommend that we go back to this position. Just good housekeeping. And if you're using the real robot, it allows me to put the bag on it and then just close the grip. So let's go back to the single cycle, get it to that position. Boom. All right, let's put the blue line at the top. Now remember, when we look at the 3D image, in the upper left-hand corner is the button to reset the cell, gets us back to the beginning, and this will allow us then to move it from the beginning, resets it. So let's watch it run all the way through. Let's do a single cycle. Well, there you have it, ladies and gentlemen. That's robot number 4. To finish this off, to get credit for your work, be sure under program flow, you go RE for remark. Make sure you put your name. Add that to the list. Remember that remark does not interfere with the operation of the robot, but it does give you credit so that you have your name written right into the program. It keeps the evildoers from printing your program and signing their name and trying to turn in your work. Put the blue line at the top, go to File, and you notice then that with that at the top, you will have the option now of printing the program and then sending it to the printer wherever you're at. Hopefully this is the one in my room or in wherever you're at. as you're working on it, and then hit the OK button, and then it'll print up only the program itself. So pick OK, and it'll send it off to the printer. Well, that concludes robot number 4. Thanks for coming. We are now going to proceed to robot number 5. Welcome back to our video series. We are working with the Intelitek ER4U robot, and this in our series, this is robot number 5. What we're planning on doing today is taking 4 cylinders that are stacked up on one another, and then we're going to unstack 3 of them. This is just a practice exercise of the things that we've done so far. Using our cell setup, we're going to set up the simulator and then move to Robocell in order to write the program. So start off with a new folder. Our factory floor moves up and down by using the roller ball. When I push down on the right mouse button, I'm able to zoom in and turn. The new object folder should pop up automatically. Remember that it's this icon here at the top that allows us to then open it back up in case you lose it. The robot is at the top of the screen. Pick the robot itself. The 4U should be the only one listed. No slide base, and then it automatically throws it on the factory floor. Let's put a table underneath there under General. Let's grab this table. 2 things we can do with the table. We can change the tabletop color. I'm going to go to this yellow today. Leave the table size the way it is. Our table is big enough for these simple exercises. As I pick OK, then you can place it anywhere on the showroom floor. And then by grabbing the hand, which is the drag object, we can move it. And I like to see it, the robot, in the center of the back side of the table, so we have all this real estate in front of us to be able to put our objects. Today we're going to cylinders. We're going to do 4 cylinders. We'll do red. Place the first cylinder on the table. You have the 3 options: color, material, and size. I don't ever change the other 2, and please don't change the 40 diameter, 40 height, because then that makes us our programming a little more difficult. Material I typically don't change. You can if you want. And then using the color schemes. It's always important, especially when you're stacking, to use different colors. And when you're using the different colors, make sure that they're distinct enough so that they don't fall in on one another. This is not the most expensive program, so our simulator works fine for what we need to do. I suggest that right away you double snap on that and give it a position. And today we're starting off our cylinders at 300, -200. And that way then I can stack the other 2 on top of that. Our number 2 cylinder is going to be blue. Let's take that blue. Now, zero in on the arrow, so you're right in on top, so you get the cube. If you put it on the table, you'll never be able to restack it, so you want to do that right away. If you're putting the positions in, it just makes it easier for the next one to come on. 300, -200. Our next one is green. Let's go get it. Green, let's use, we could use that green. That one's kind of a greeny green color. 300, -200. And then the last one, let's use yellow. And the colors really don't make that much difference. All I'm saying is that when you put the colors out there, that they are different enough each and every time that they don't fold within one another. But it does make a difference though on the position, because our robot's going to need to find those. And we've already given the positions so that when we import this into our Robocell, that we know where these positions are. So that ends that. Make sure that you save this. I recommend to save it to the desktop. That's the easiest place to find our work each and every time. Call this then robot number 5, and then hit save. I suggest that you leave this open on the screen so that if there's a mistake that we can go back and find it and then correct any mistakes that you may have. But we've saved it already on the desktop. So now let's go to the Robocell. Robocell is where we actually create the program. Let's file new. Again, a couple of things to do right off the bat. Number 1, switch it to Pro, because then that allows us to use all of the command lines and then allows us to expand our teaching position box. Put the home position. Each and every time our home position is the same. Position 99. I would say make sure that you commit this to memory. Our X is 130, Y is 0330. -90 is our pitch, and roll is 0, so teach. So now we have our teaching position. Let's go get our robot. So file, import the picture. On the desktop you should find robot number 5 and bring that in, import it. I like to scooch it down so if I'm working on this side of the program, that way I can see what I'm doing, and then as I write the program it doesn't disappear. If I were to click on this side, anywhere on this side, the image goes away and I gotta go back and get it. So with position number 99 recorded, let's add that to the list. Always to go linear. It's just a lot nicer. The robot then doesn't have to make up its mind where it needs to go. And then open the grip. Under the options tab, remember that when we are working with the simulator, that we have the X mark, the check is at the simulator, and that way the two programs are working in concert with one another. Put the blue line at the top, run a single cycle, and you should see the robot move. And open up the grip. Again, in the toolbar for the Robocell, you have the 3 ways in which you can move it: single line, single cycle, and continuous. When you hit on continuous, it runs by itself and you never have to go in and do anything with it. It'll just continue to cycle over and over and over. Under the run menu, you have those 3 choices. Again, single line, single cycle, continuous run, or if you hit the F keys, F6, 7, and 8 respectively, and the big one here, stop. Either touch this, you can hit the F9, or you can go up into the corner and hit the stop button, and that immediately stops your robot. So we have position 99, we had the open grip, so we are ready now. Now again, notice that I picked a yellow top, yellow cylinder. Maybe not such a great idea, because once they sit on the table they kind of disappear with one another, but we'll go with it today. Just know that maybe not the best decision to do that. So we have positions 1, 2, 3, and 4, which are our cubes. So let's go ahead and do that, because once I start that, then I only have to change our Z position. So position 1 is our red cube. It is sitting at 300, negative 200, 17.5 at the table. We're always going to leave for all these cases, the pitch and roll will be the same, so I don't have to change that. And now hit the most important button, teach. Position 2 is the blue cube. The only thing I have to do now is add 40, which turns to 57.5. Position 3, 97.5. Position 4, 137.5. All it is the addition of 40 milliliters to each one. And position 5 then is over the stack. So we'll go right to the 200 mark, which gets us in and out of the cell. And there we have it. So now positions 5, 6, and 7 are going to be listed all across the top. So in our particular case, position 9 and 6 are related, position 10 and 7, and position 11 and 8 are related. So let's do 6 and 9. 6 is over the cell at our Z of 200 and moves the new cylinder to 300, negative 100, and position 9 will put it at the table. So let's do 6. So 300. You look at your handout then, this is 100, and we're above the table at 200, so we'll teach. Position 9 puts it at the table, which then just means a 17.5 change, and teach. Positions 7 and 10 are related. So position 7 is 300, 0, and 200. Teach. Position 10 places it at the table. 300, 0, 17.5. And teach. And position 8 and 11 are related. So 8 is 8 is going to be our blue cube. 8 then is 300, 100. 200. 100. Teach. And its related position is position 11. 300, 100, 17.5. And teach. All right, so there is our, should be 1 through 11. 1, 2, 3, 4, 9, 10, and 11. There they are with our number 99. Okay, great. So let's start adding our, so we want to move yellow. So yellow is the first one we want to get. So we need to go to position 4. So we said that was position 4. Be sure to use the linear one. Position 4. Oops, I don't want to swing right down to 4 though. Remember that we always want to talk about going up in and out of the cell safely. So if I double snap on 4, I don't actually have to delete it. I can just give it another number and change it to 5. Now give it our 4 Now since the grip is already open, let's run those two with a single cycle. So it will go from 5 to 4. Sweet. Close the grip. Otherwise you're going nowhere. Alright, so what do we want to do with this yellow cube? We want to go from 5 to 6 to 9. So position 5 gets us straight up out of the cube. Our new position is 6. And according to the diagram on the piece of paper I've given you, we're going to position 9. Sweet, let's do that. So 5, let's do the cycle now so we get the 3. So 5, 6, 9. Yeah, baby. Now we want to leave it there. Remember that you have to open the grip. Open the grip, now do a single line now. Straight up in and out of the cell. 6. That's how we got there. Let's back it out at 6. See, now you can see how the yellow one kind of disappears by using the same cube and the same color. I guess yellow was a bad choice for me today. But I'm not re-recording this guy, so it's just going to be forever a bad choice. So 6, 5, and then position 3 to get the green one. So we're at 6. Go to position 5. Position 3 is where that cube is. I'm sorry, where that cylinder is. And then we'll want to close the grip. So let's watch that happen. So we're at 6. So let's cycle it through. Booyah. Now we want to move it to the new position, which is then going to be 7 and 10 is where we need to go. Always straight up out of the cell. Position 5 gets us up. Let's watch that happen. Now let's add 7 and 10. 7 and 10. Seven to 10. Leave it at the table. You got to open that grip. Okay. Let's go get the blue one. Safety first. Get straight up out of the cell. Now we're going to go 7 to 5 to 2. 7, 5 to 2. And I'm thinking ahead, I'm going to want to close the grip. So let's do that. We're right here at the open grip now. Let's run that cycle to the end. 7 to 5 to 2. Close the grip. Okay, we got to put the blue one somewhere. To put the blue one somewhere, it's related to position number 8 and 11. So let's add those to the list. Remember, when you're going up in and out of the cell, this one then, position 5 gets us up and out. Position 5, remember, that's straight up. Always a good idea. 8 to 11. So 8 is our new position. According to the diagram, we want it now to go to 11. And then open the grip if we're going to leave it at the table. So let's watch that happen. run a cycle. So from 5 to 8 to 11, open the grip. Now we're all done. But again, if we immediately take off for the home position, we could run into something. Always to our safety advantage, always to go straight up in and out of the cell. So position number 8 was the one associated with getting it up out of the, straight up out of that cell. 8, straight up. And now head for home. Position number 99. And close the grip. Some good housekeeping things. We're able to put the bag on it, put the robot away. Remember to do that. And there you have it. So, let's see if it'll run all the way through. In our 3D image in the upper left-hand corner, we can reset the entire cell. Let's zoom in. Let's work these buttons here so I can zoom in and take a look at what I want to do. Watch it work. Put the blue line at the top and run a single cycle. Well, there it did it. Got the bell. So we are done. The robot has successfully moved the 3 cylinders off the stack. Remember that we want to be able to record your name. Under the program flow, we have the remark. Type your name. Always nice, looks better in all caps. Put the blue line at the top. File. This, if the blue line's not at the top, our print program isn't going to be able to mark that. Pick the printer wherever you're at. Pick OK. And then it'll print your program and then put it up on the desk. Put it, and there you have it. So hey, there's our robot number 5. So stay tuned. We'll be moving into robot number 6. Hey, welcome back to our video series. This is a series that we put together for the instruction of the Intelitek robot, the ER4U robot. We have a number of applications that we've done. This is robot number 6, in which case we're going to use a couple of new commands. We're going to use some new pieces that go along with this. We're going to add a couple of bins with our cylinders. And the object of this exercise is the robot is used to move raw materials through a manufacturing process. In many cases, the robot is asked to wait for a part to be machined before it can be removed and placed in the next process. The manufactured part will need to be placed differently in each jig or fixture depending on the operation. In order to accomplish this task, the roll and the pitch will be adjusted in order to place the part correctly. So what we're asking the robot to do is, as it places itself or places the cylinder on the table, we're pretending that this would be then some type of manufacturing process to where the robotic arm then needs to move back and then wait for this process to occur. Once the wait period is done, then move back, grab the cylinder, and then move it on to the next position. So as we do this, we're going to have 10 different positions. We'll use the wait command, and then we'll, in this particular case, we'll adjust the roll and the pitch a number of times. Actually, not the pitch, but we will adjust the roll to have the claw then move, and you'll see how it rotates. So for our cell setup then, let's go ahead and start with a new project. As we have done in the past, know then that the factory floor, as I move the roller ball, moves forward and back, and when I hold the right mouse button down, I move forward and back. To put the robot out there, no side base. The minute I say OK, it automatically places the robot above the manufacturing floor so I can slide a table underneath it. The table is available under General. This time I'm choosing not to change the top. Leave it as the way it is, and then leave the table size. I can put it anywhere out there and then move it underneath the robot. I usually like to leave the robot to the back side of the table so I have all this real estate to work with. In our efforts then to add some storage devices under storage device, we're going to add 2 bins today. We're going to put one bin on this side and another bin on the opposite side. Just like all the other objects, we can rotate, we can rename, and we can give it a position. So in this case, I want to give it the position. This one will be located at 250 and -260. Our second bin position will be 250 and 280. We're going to place 2 cylinders inside the first bin. Red will be the first one. We'll locate its position at the same as the bin, 250, -260. And then we'll place the blue cylinder on top of the red. Be sure that you really zoom in. Make sure that blue then sits on the top of that, giving it the same position as 250, -260. Okay. So this is all that's required of our setup. Go ahead then and file, save as. Make sure you put it to the desktop, is the easiest place to find it. And then let's save this as robot number 6. Okay, I did it earlier today, already exists, so that's okay. And we'll have it set the way we want it. Now, I'm going to go get now our Robocell. I have taken some shortcuts here though, in that I've already prepared this to accept our device, and I've already set up. So this is what we just finished. for our cell setup. But in order to save some time on the video, I've gone ahead and recorded 10 positions, including our number 99 position, which we know then is our home position. And we could add that to our program immediately. Number 99 and open grip. So let's just watch those two perform. And there you have it. Now, I have the position set up, and I have them in a dialog box right now. So what I'd like you to do is pause the video, and for each one of the positions, I want you to record the XYZ. So for position number 1, it would be your X is 250, your Y is negative 261, your Z is 20, your pitch is negative 90, and your roll is 0. Position 2, you see here, position 3. So make sure that you record the XYZ. Don't record the joint. So please pause the tape. Please pause the video so that you can record all the 10 positions that you're going to need, and you'll record it then in the box as we expand right here. So pause the video now and enter your 10 positions. So welcome back. The positions that we'll use will be the 1 to 10. Position number 1 being the red cube, position 2 being the blue cube, and we're going to place it in 2 different spots. So position 2, 3, 4, and 5. Then we'll do 6, 7. And then position 8 is over the bin, and position 10 will be the blue cube, and position 9 will be the red cube. So let's start adding those positions right now. So since we have an open grip, we can get started in adding our positions. So I want to get over to position 3, which will be over the bin. Position 2 is our blue cube. Let's watch that occur. All right, I'll want to close the grip. And then let's going to put in a series of commands here. So position 3. And let's move over to position 4. Let's do position 5. We'll be placing it on the table. Let's do that much. So let's watch it move through 3, 4, and 5. All right, so you see position number 5 then has a roll, so you can see then that we're asking it to move into a specific position. I'm going to want to open the grip at this point and then move back to position 4. Let's watch those two. Now the robot is to wait here. The pretend manufacturing process is occurring. I'm going to move this to this side because I need to have a wait command for this robot to be able to wait. And I'm going to put in 30/10 of a second. That seems to be enough time for us to watch, and nobody loses their patience with that. We can move this back. So the problem is if we lose this and we close it out, it doesn't necessarily, as we reinstitute it on to the program, it doesn't necessarily fall right back to this position. Sometimes it enters back at a weird place, and then we have to reset the cell and then start from the beginning. So now we're pretending to have waited for the manufacturing process to occur. We're going to now reach back for number 5. We're going to close the grip. We're going to move to 4 to 6 to 7, open the grip, and then move back to position 6. So 5 allows us to grab the cube. We'll want to close the grip. Then let's go back and do 4, 6, and 7. So 4, 6, and 7. Now this is all on the handout of these positions. So let's start here. So it's going to go back to 5, close the grip, and then it'll do 4, 6, 7. So let's do a single cycle from there. Okay. We want to open the grip and then move it back to our position 6, which will be our wait position for the process to occur. And then add our wait time. Now here's the wait time. So rather than reinstitute it, you can also copy by right-clicking, copy, and then paste, and then that would give us our same wait time. You can even adjust it if you want by double-clicking on it and putting in a new number. So it's weighted now, and now let's take it to the bin. So I'm going to then go back to number 7, where I'm going to close the grip, go from 6 to position 8 and position 10 to drop it in the bin. So here we go. 7, close the grip, back to our position 6, to 8, puts it over the next bin, and then to move this down and place it in the cube, we want, or I should say in the bin, is position 10 is the first position within the bin. So let's start this then. Start it with our wait time, and then let's see how it goes. All right, it's there. Let's open the grip, and then let's move back to number 8. So open the grip, open the grip, and back to 8. Okay, beautiful. Now, we are going to really do a shortcut here. And since all of the positions are the same for the next cube, all we have to do is change out 2 positions to make this work. Position 2 was our blue cube. If I change that to position 1, that would be my red cube. Position 10 is the blue cube in our final bin, in our finish bin. If I change that to position 9, then that would be our red cube on the top. So I'm about working smarter rather than harder. So if I hold my mouse button down, hold the left mouse button down, I can blue in all of this, and then right click and I can copy. Put the blue line at number 27 and I'm going to paste, and it instantly provides me with all the positioning that I need to make this work, except for, as I said, I'm going to go in here on the position 2 and change this to 1, and down here at the end I'm going to change my position 10 to position 9, and everything should remain the same. So let's see once. So let's go back to the top and start right from here, as line number 27 is where we added the next list. And let's see if indeed it can do the red cube. So I'm going to run a single cycle and let's see what happens. All right, so we're putting it on the table. Back to position 4, here's our weight. We are simulating now that the machine process is occurring. It's complete. Move it now to position 7. And wait. So now position 9 would be where the red cube would go. Back to position 8, and all we need to do now is home. So let's head for home, position 99, and let's close the grip. Beauty. And there we go. Hey, it's complete. So here's all we have to do now. Now that we have it all complete, we are going to reset the cell, and we are going to ask, whoops, where to go? We are going to set this up so that we can watch it from the top. Start from position 99, and I am going to pause the tape momentarily And we'll set some music, and then we'll start it.
Grammarly helps you work more efficiently, which makes accomplishing your work goals easier than ever before.
There is our...
Get full sentence rewrite suggestions so you can say what you mean faster.
Hope you enjoyed it.
Powered by over 1 billion user interactions, Grammarly's instant suggestions help you quickly polish your writing.
And we'll see you on,
Use Grammarly to select multiple corrections at once. Instantly.
Hey, welcome everybody back to our online program, Robotics and Automation. We're doing Robocell today. This is a series of lectures that we're doing in presentation to walk you through the ER4U robot from Intelitek. Today's presentation is about remarks and loops. A loop is a very, very handy program that allows a robot to, let's say, move a casting from the assembly line maybe into a milling machine, wait for the milling machine to do its business, and then pick up the part and then put it back into a bin. Now, this machine could be running and moving hundreds and hundreds of parts And if we create a loop, we don't need to create a specific control line for each of the parts. We can create a loop for the robot to be able to monitor itself in terms of the number of parts that it uses and the number of parts that it picks up. Today we're just going to use 4 cubes and move 3 of them, and then we'll create the loop so that when the robot gets ready to pick up the 4th one, it'll know that it's not supposed to do that, and then it'll put itself away. So one of the things that we haven't used yet is a command called the set variable. And in the remarks, I think we've probably talked about them, in that anytime that you put a remark in the program, it's something that the robot doesn't read. But it's certainly important for the robot then to have that documentation for somebody to read it in case you need some clarification on some stuff. And it's nice for that line item then to be able to put in there so that you have some understanding of what the robot is intending to do. So let's go ahead and use our cell setup just to start and put those component pieces together. We've done this before. Remember when you start new, you have the factory floor. As you roll the roller ball back and forth, it turns the factory floor back and forth also. Then if I hold the right mouse button down, I can zoom and then I can turn the screen. The new object list is over here on the left hand side. If you happen to lose it, it is located up here in the toolbar at that point, and you can touch it and then you can actually bring it back. Sometimes you get by accident it goes away. The robot, there's only one robot that needs to be put on the screen, and that is our 4U robot from Intelitek. We're going to put no slide base out there, so then when you pick OK, it automatically puts itself out in the middle of space. Don't panic. We then are just going to go ahead and we're going to put a table underneath there. The table that we use for all of these exercises is under General. We can pick a fancy color. I always tell folks, though, be sure that you pick the lighter of the colors, because some of the cubes can disappear if you use dark colors. I'm going to use this sand color today. I guess I've never really used that one too much. Doesn't look too much different than the one that we can default to. Now remember then, our object move, I like to put the robot in the back center of the table, because then I have all this real estate out here to do what we need to do with the robot. The materials that we're going to use today are cubes, and we're going to take those cubes then and stack them up. I guess I really didn't specify which color to use, so you can pick the colors for yourself. Take the first one out of the chute. You can choose the colors that you want to do today. Don't choose 2 colors though that are really, really close. Try to use distinct colors that are different, so that when you place the robot cubes on top of one another, that they don't fall down on top or fall through each other. The materials, makes no difference what material you use. I just leave it at plastic, and then don't change the size. The 40 millimeter by 40 millimeter by 40 millimeter are the actual cube sizes that were used on the real robot, so leave them just as is. All right, so we'll put this first one out here, and when you double snap, you got 3 choices to do stuff with it. You can rename it, you can rotate it, and you can give it a position. So the position then that I want to give with it is a position here, and we're going to start it off as the X is 310 and the Y is going to be negative 250. So we have it setting over there. So that's a pretty good spot right there. What I might want to do though is, since this is pretty close to the 45-degree mark, I'm going to rotate that and give it 45 so that when we go over and pick it up, that we're picking it up on the side, on the sides of the cube rather than on the corners. Now the next one, let's grab, oh, I'm feeling a little blue today. So let's put that on top, rotate 45, and then give it its position. Remember that these positions are all the same. 310, negative 250. The next cube, let's go ahead and grab a yellow. There you have it. Rotate 45. Position 310. Negative 250. And the last one, let's go ahead and use this brown. Okay, so you can see that I have 4 distinctly different colors. Works certainly a lot better. And there you have it. And rotate. 45. Okay. So there you have it. So there's what we start with. And really, this is all we need to create robot number 7. So all we're going to do actually is just, we're moving 3 cubes over to another spot on the board. But it's a very simple operation, but the real big deal here is how we go ahead and do this. And by creating the loop, we can move that stack of cubes could be out of a bin of thousands, and we would use only about the same number of commands, you know, that we would use, you know, maybe 20 or so commands in order to get thousands and thousands of parts. So what I recommend then is, you're on the computer, let's go ahead and save as. This happens to be robot number 7. Let's save it to the desktop. So this is just kind of the way I've been keeping track of these. Robot number 7, and then we'll come back and then grab it. All right, so let's move over to Robocell. And Robocell then is the program that we'll actually use to be able to import the robot pictures and then be able to create the programming in order to give ourselves this loop control. So let's do File, New. One of the first things that you want to do when you get over here is make sure that you click on the Professional. We are professional robot programmers. What that does is allows us to get more control on what we're going to do. Take a look at the, there's only like 3 under each one of these tabs. Under the simple one, when I click under the Professional, we get multiple choices to use under each one, and certainly we will use them to our advantage. Also down here at the bottom, it does expand our position so that we can actually create the positions that we need. Now, under File, 3D Input, you know, so we want that model to work with. So let's go find Desktop, and let's find robot number 7. All right, so there's just what we created, and we're going to use that now. I like to put it over on this side because I can write the program, and it's kind of a pain if I don't, because then the image disappears, and then I have to go back and search for it. And if we lose the image, a lot of times we lose our place within the programming because it kind of loses its mind. So we can start with here. So one of the first things that we're going to do is create the home position. Home position is always at position number 99. And these numbers you need to put to memory. 1300330, -90. And the roll is 0, and the most important spot, position, move that you make right now, other than memorizing these numbers, is hit the teach position. Now that adds then this to our ability to put this position up here on the program line. So you'll notice then I always use it, always go to the position with the linear. Linear is always straight line. Then the robot doesn't have to make any decisions, and then I know where it's going to go. So let's put number 99 in that control line and open the grip. So let's watch the robot do that. Put the blue line at the top, and then let's do a single cycle so it'll run both at the same time. And notice that we did get that. Something that I haven't done a lot of, and that is to let you know, up here in the left-hand corner is the little button that you can actually reset the work cell. So if something happens to where you're in the middle of it and you have impact, or you forget, you make a mistake in the program, you forget to open the grip and it smashes into the cube or the table, you can always reset it. You haven't damaged anything, so you can always reset it back to that. So let's go then, 99, single cycle, and boom, there it is. Okay, again, the way that we move the robot, we have the three choices. We can run it individually by a single line. We can do a single cycle, which I just did, and then you can run continuous. Continuous means you never have to touch it again. It just keeps going and going and going, just like the Energizer Bunny. The other place to find those is under the Run menu. You'll see those three choices again. Single line, single cycle, continuous. And then you have the stop button. Or you can use the F keys. I guess those are nice too. I guess I've never been used to using the F keys. 6, 7, 8, and 9 correspond to the same list. The stop button is here. You can get the robot to stop anywhere within the control system, and actually it will restart. If I stop it in the middle of a program, I can restart it again right from the middle. I don't have to go back to the top. All right, so let's start writing some things. Well, but one of the first things that I have to do is that I have to start labeling some things and creating some names that we wanna do. So when I go to pick up these cubes, we're gonna need to set a variable so that instead of using a number, I can actually use a name. So let's go ahead and set a variable. Now this is a pretty common one, and I continue to talk about it, and I use the name for this. So you can set a variable such as the word home. And what position would that equal? Well, we can set position number 99 as home. So now when I write my program, I can either bring in the word 99 or I can use the word. The other thing I'm going to do is when I go over and I reach down to grab one of the cubes, another word I can use is picking up. Some of you should be picking up your bedroom and getting all the clothes up off the floor and helping pick up the stuff off the couch and all. Okay, so pick is a good word. So we are going to assign the word pick to our cube, so that when we go down to pick up the cube, we are going to name these then as position 1, 2, 3, and 4. So the top one that was going to be used would be the first one that we grab, and then that would be pick will equal position 4. So when I go get the next cube, that will be position 3, the next cube will be position 2, and the next cube will be position 1. So we'll need to create some type of mathematical formula that each time through, we need to subtract something from that 4 to make it position 3, position 2, position 1. So that's one way of doing it. The other one is that you could have started at 1 and then work down 1, 2, 3, 4. I'm just choosing to go 4, 3, 2, 1. The other thing is you could create another loop over here, and that would be the word drop. So when we set the cubes down, you could also use another word, and you could use the word drop if you'd like to. I guess I'm going to choose not to do that today. You know, I'm thinking that one set of variables is enough rather than actually trying to do 2. We'll just do 1, and it'll make our life a little simpler. So we're going to be looking at positions 1, 2, 3, and 4 are going to be crucial to our stack today. So what we're looking to do then is to have this robot move that when we get down to the number 1 position, we don't want that robot to pick that one. When we get the 3 move, then we'll want it to be done, and we'll go from there. All right, so here are the first things that we want to set. And we started the position here with 99, open grip, and then we'll begin to do the first 2 that we'll change the name here to number 90. So we'll use that a little bit later on, but I could have actually started this earlier. But you're going to see how these 2 are actually going to work out here at the end of our program, because we want this robot to go to the end of the program when we moved enough cubes, and in the end position, or something that we're going to label as end, and we'll want it to jump to the end of the program, we'll have these 2 housed in that particular area. So once we've done this, let's go ahead and start some positions, and I'm going to kind of name them as we go along here. I'm going to move this back over to the other side, and then we'll start creating some positions. So my first position is going to be position number 100. I like to use some of the bigger names, and that position is going to be over the top. So we'll come back to position number 100 each and every time, which will be our crucial point where the robot has to stop and think about what it needs to do when we get to position number 100. And 100 then would be these same numbers as we put in for the cubes. Our cubes position, 310, negative 250, and I guess we can go a little lower. We can go through and pick, let's say, 250 maybe. We want to be higher than what we are on the cubes, and we want to make sure that we don't need to put in a roll because we already turned the cubes. So then position 100 this is all we need to do, and let's hit teach. So now let's address those cubes. So position number 4 is that first cube up there, 310, 250, and if we count out the cubes and add 40 to each one, we found out that cube position has a Z height of 137.5. And let's teach that. All right, so let's do position number 3. Position number 3 is the yellow cube. Has the same numbers. We just have to reach down a little further. That would be 97.5. The blue cube is in our number 2 position. Its point is 57.5. Teach. You're gonna keep hitting that teach button, and then number 1. Number 1 is at the 17.5. Now we may not use position number 1, but it's always nice to have. Okay. So now we have to move it to a new position somewhere over here. Let's start those out. I have the form here in my hand of where I want these new cubes to go. So we want them, the new stack, to go to 200, positive 55, and up over the stack, I think we were using 200 then. No, 250. I changed it up a little bit. And we're going to call that position 101. So we're going from 100 over here to 101, and now let's redo the stack. So we could use position 5, 6, 7, and 8. Let's just go ahead and really put some random numbers out there. Let's call this position 12. And remember then that this would be 3 cubes. 97.5. Teach. 11. 57.5. And the one on the table, position 10, is 17.5. All right, so there are all the positions that we need to do. So 1, 2, 3, 4 are the positions that you see the cubes in right now. And positions 10, 11, and 12 are going to be in the new position. So let's create a series of commands to go get that first cube and then to put it over here on the other side. So I think we've done that before. So let's have the robot then go to position 101. No, 100. So hit the straight arrow. Position 100. Grab our robot cube at position number 4, but we're not going to call it number 4 because we already have a name for it. Let's call it pick. Now let's close the grip. Let's have it go back to number 100. Let's have it go to the new position, 101. And let it go to position number 10. But that other stack, you know, we could make our lives a little simpler. By giving that a name. So I'm going to go back right up here and I'm going to insert that command right there. So why don't we give it a name? Let's call that first one drop, and let's call it position 10. So rather than use a position 10. Why don't we just say drop? That would be our first drop. There we go. And we've already named it here as position 10. So after we've set it down, we then can go back to 101. Oop, what should we do though? Remember to open the grip. We got to leave it there. So we can go back to 101. Go back to 100. Wait, go back to 100. And then we could go back and have it get another cube. Well, let's just reset this to see if it'll move the first cube. And let's start it at the top, and then let's see what happens. So there's position number 4. Remember that we changed that name. We called it pick. Drop now is position 10, which then we set it up on the table. And now we're back to 100. So we're ready to go to get the next one. So here's where our mathematical formula comes in, that we want the robot at this particular point to make some decisions. So we need to start adding. So position 4 is no longer there. So we need to get it to go to position 3. So if I have 4 and I need to get to 3, that means I should minus 1. So let's write that. So we want to do pick. So change our pick to pick. Now over here on the side you can grab what mathematical formula you want, and we want it to minus 1 each time it goes through there. So there you have it. So now pick is a minus 1 so now it becomes a 3. Now let's, as long as we're here, let's do the same thing with our word drop. So drop now has to go from 10 to 11. So our drop then really needs to be drop plus 1. Plus 1. So now we've just changed drop, which was 10. Now we made it 11, which would be the one that we wanted to stack here at the top. But we have to somehow get it back to the top so that it can restart itself, so it can get it back going again. So I put here position 100 twice. I really wouldn't need to do that. We could eliminate this one because eventually it's going to get over to 100 anyways. So we could cut this out so we wouldn't need to do it twice. Let's just cut that line and then say okay. So it's gone to beginning here, open. So now home, pick, drop. Okay, go to 100. Pick this guy up. Go to 101, drop it, open the grip, go back to 101. Now when we send it back up here, it's going to go back to 100 anyways. But instead of getting over here and making the decisions, let's just keep it at position 101. and it'll make its decisions over there. But somehow we got to get it back over here. And here's where we come in by adding something called, we want it to get back to the top. And this is called a loop. So we're going to take and add a label right here. So we have to have a place for it to go back to, and these are called labels. So since we're talking about loops, let's just have it jump to the word loop. So as soon as it's done here, let's have it jump back to that loop. So that's where we want it to go. But we really should make some decisions right now. So every time it goes through, it's going to take one away from our pick stack. So 4, 3, 2. We don't want it to move the last one. So what if we add another little formula here? Let's say, and we want to if jump. Let's say then that if pick is less than 2, now less than, is that symbol there? Less than 2, we want it to jump to the end. So now, as it runs through this and continues to go, each time through, started at 4, now we got it to 3. So it jumps back up, grabs position number 3, comes down through, the next time through, turns it into 2. Well, is 2 less than 2? No. That's still a false statement. So then it's going to jump back to the top. So let's put this simple jump 2. So when it gets to this position, if this is false, it's going to go right to the loop and go back up to the top. So pretend this one isn't here. So as long as this continues to run, it'll go and go and go and go and go. Obviously, though, with our pick number 4, we're going to run out of cubes in a hurry. We could make that 1,000,000. And then we would run around and around, but since we don't have that kind of time, let's just, we just put 4 of them on there. But, so the first time through it's position number 4, then changes to 3. Is 3 less than 2? Nope. False statement comes to this line, jumps to the top, runs the next time through. Turns it to 2. Is 2 less than 2? No. Jumps back to the top. This comes through now, and it then turns it into 1. Pick minus 2 turns into 1. So is 1 less than 2? Yes. So now we're going to send it to end, and then let's put that label here. Oops. No, I just don't want to type that in. I got to make a label. Label. L-A. There we go. And what do we want it to do at the end? Well, we want it to go to home. Now remember, we gave home equal to number 99, so we could use the word home, or we could put 99. Let's just put home, since we've labeled it already. And what do we need to do? Just for good housekeeping, we wanted to close the grip. So there you have it. 21 lines. You could put a remark in here. Remember now, this is, I typically have you do this, put your name here. Put your name here on this line, and then you can print it. To print the process, put the blue line at the top, do File, and by putting it at the top, you actually then get this thing to light up. This is the printer in my room, or wherever your printer is, and then hit OK, and then it'll send it off to the printer. And that way it'll only print this much rather than printing the picture and everything else. So I've lost my image, so I'm going to have to go get it again. But we know where it is. It's on the desktop. So there it is. And we'll want to reset that cell so we can get it to start. So we are done, really. So let's see if this thing will do what it needs. So in a recap, we always started at the home position and we opened the grip. We set a series of positions so that position 1, 2, 3, and 4 are our cubes, and we positioned a 100 and a 101 for our movement across over the top of the cell. Down here at the bottom then, I just chose some bigger numbers. The bigger numbers then, we started off at number 10, which would have been at the table. It would get to number 11 and then number 12. So we did two things then. Each time it runs through, it will subtract 1 from our pick, with it starting off at our first top. 4, then 3, then 2, then 1. Down here, we decided to use the position number 10 as a drop, and then we told it to drop +1, +2, +3. So what are we monitoring between these two? Well, we're monitoring the ones that say pick. You can do either one. The robot doesn't care, but we've just used, we're saying then that the pick stack is more important than the drop stack. So let's see what happens. So let's get it up at the top. Let's run a single cycle, and you'll notice then that even though it's a single cycle, we still have these loops that it'll continue to move as long as our program is set up. So now it moves to position 10, which we call drop. Open the grip. Now we've done our math. So now we've gone to 3, and now 11. So position 3. But it did say then that position 3 is not less than 2. Here we go. Now this should be position number 11, which we said was on top of that. Sweet. Here we go. Now it changed. So now pick is 2. Is 2 less than 2? Nope. So let's get 2. And now we've changed it to position number 12. Now at the bottom, as we get here, now it's pick is 1 and drop is 13. Of course, we don't have a position 13, but we don't care. But there you have it. It immediately then found out, let's do the bell. It already made the decision. So when we changed pick and when it got to 1, 1 is less than 2. All right, jump to the end and then put yourself away. There's a successful program for understanding how loops work and using a remark. So, hey, thanks for coming today. We're going to end it right here. And we'll see you next time. Hey, welcome everybody to our robot series for the Intelitek ER4U robot. Today we want to look at a command called the Go Circle command. And what that does is it allows the robot to walk over, pick up a part, and then be able to navigate around difficulties by using a third command, I should say a third setting, that would allow the robot then to navigate around pieces in a circular motion. This intermediate position, though, the robot doesn't stop at it, it just goes through that. Rather than a straight line, it will do a specific arc that we ask it to do, and it is a specific command that we have. So we're going to put a couple cubes on the, or I should say cylinders on the table, and then we'll pick a spot where we want to have them come down. What we're going to call this, though, is we're going to call this Robot 7A, because I inadvertently created a Robot 7 with our loops and remarks when this truly was the Robot 7. I couldn't find it, so I made a mistake, and I'm not re-recording another part. So we'll just look at this then as a Robot 7A. So let's go ahead and get the factory floor open. Remember again that by using the roller ball, I can back and forth this way. When I hold the right mouse button down, I can turn and zoom. By this time, you should be able to put the robot out on the factory floor, and then provide us then with a table. The table is under the general. Let's get, I'm feeling kind of blue today, so let's grab that blue and stick that out there. Remember that in order to move pieces around, we use the Move Object tool, and I like to put the robot down towards the back of the table so I have all of this real estate to work out in front of the robot. We're going to use a red and a blue cylinder today. So let's go ahead and grab a cylinder. Don't change any of the defaults for this. We'll just leave it at plastic, 40 and 40, and then leave it vertical. So when we put it out on the table, we put it right there. Make sure that you set it on the table. If you don't set it on the table, then it won't go back to that. The starting position on that is 300, negative 150. So let's get the position of 300, negative 150. And then let's set the blue one on top of that. Let's go get this blue. Again, it's kind of a big deal to when you're stacking cubes or cylinders that you have them a specific, really different color. If you try to make them all the same color, they fall in on one another. It's a little on the cheaper side software, so by using them really, really different colors, then it makes a better stack. The other thing that we want to put in there is a cube, but we're going to change this a little bit. We're going to have a cube. You can go ahead and pick really whatever color that you want here. Make it a dark color. Let's go with this brown here. But what I want to do is make it really tall. So I'm going to make it 200 millimeters tall and then stick it out here, because we're going to use this as a blocking piece for our robot so that we actually have to get around it. So that position is going to be 300, 0. Now that would mean that it's right out in front of the robot, right in the way. So we have to get around that piece in order to put our cubes on the other side. So that's the way this shakes out. This is all that we need for this robot. So let's go ahead then and save this. We'll save it then to the desktop because that's the easiest place to find it. And again, I'm going to call this Robot 7A because I already have a 7, already have an 8, You know, this particular exercise is the true Robot 7. I might go back and try to change some of these names if I can do that for the video. But we'll see what I can do. If not, we'll leave it like this, because I'm not going back to re-record, so we'll just leave it at that. So this is for the Go Circle. So now let's go ahead and let's go to Robocell. Let's leave that up though. File new, a new project. Remember that two things that we want to do. We want to click to probe because we are professionals. So that gives us the opportunity of all this. And then create a home position, 99. You need to remember these numbers, 1300330. Your life may depend on it someday. The pitch is -90 and the roll is 0. Hit the teach button. Let's add this to the program. Click here. Here's our 99. And open the grip. Alright, so let's save this and label it right away. Save project as. So I have a file I've been saving it to, robot class problems. I'll save it to there. See, I got 6 saved in here. I don't have 7 and 8. I'll have to look where I put those to make sure we have them in here. Robot 7A. Okay. Go circle. Okay. And now we have it. Right, so let's bring in our 3D image. And I don't want that one, I want the one that I just made. Oh, I don't want to save it, I want to get the 3D image. What am I doing here? Think, David, think, 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 think. Must be go circle, that must be the one. But it's not saved as 7A. See, I have a 7A saved here. Oh wait, desktop, and making more sense now. There's a 7A. There it is. That's the one we want to work with. Had to hunt it down. Alright, so we've already created the home position. I'm guessing then that if we put the blue line at the top and run a single cycle, robot comes down and opens. As in before, there's the 3 positions that we have for single line, single cycle, and continuous. That would be in the toolbar. For the Robocell toolbar, it's also under the Run menu. You have the single line, single cycle, continuous. Also then you have the F keys, F6, F7, and 8. And then if you really need to have an emergency stop, there it is. In the Run menu, F9, or on the toolbar, it's right there. So remember, you have 3 ways in order to make things go. The toolbar, the Run menu, and then the set of F keys. So what we're looking to do now is to be able to pick up these individual cubes and put them over here on the side, but we want to make sure that we have that Go Circle command so that we move around this particular piece. So, oh, rats. And let's just reset the cell. So let me put in some positions. On the handout that I would give you, there's position, we have a position 1, 2, 3, 4, 5, 6, 7, and 8. So let's do that. So position 1 is listed on our position sheet. So let's record that. So position 1 is the same as our stack of cubes. So the stack of cubes is at 300, negative 150. So over the stack is 100 and negative 90 is 0. Okay, teach. Position 2 is the blue cube. It is at 300, 150, and 57.5. If you remember that these are set up at 40 millimeters apiece, and position 1 then nope, sorry, position 3, well, if we do it the way I got the sheet set up, I'm calling this one position 6. I guess I don't know why I did it that way, but that's what I have. So I have 2 over 6, so this is, I don't know, but here it is. 6 is this one, and this would be 17.5. I don't know what I was thinking with this one. Okay, so position 3 is our go circle position. And position 3 then is going to be a position that is going to be in and away from the cube, so that is our go circle command. So position 3 then would be 300. No, that's going to go to position 400. So it spins out and around that. Our X would be 0. This would be 100 and negative 90. So that's our position 3. So it moves up and around this point, and that 400 then should make it easily around that. And pick teach. Now, position 4, 5, and 7 then are the new positions. Position 4 is where we're putting it down. So it's a 300, positive 150, and that would be the 100 mark and teach. Position 7, 301, and then 57.5, because that would be where the red cube goes. And then position 5, it would be where we end up with the blue cube, 17.5. Okay, so I should have 1 through 7 recorded along with the 99. Okay, so let's go ahead and start programming. So we want to come down and pick up the blue cube, which is over here to position 2. So we want to get to position 1, which is the first one up there. So just for shits and giggles, let's go ahead and run it to that point to make sure that that's where we're going to get it. So let's put the blue line at the top, run a single cycle up to that point. And it is. So that has to come down a little further. So what? Oh, that's just the 100 that we want. Okay, not a problem. All right, so position 2. Let's reach down and grab that cube. There we go. Let's close the grip. Single line. Okay. So now let's see if this position 3 works. So let's go back to our position 1. And now let's do that go circle. So I want to go from position 1 No, I take that back. My target is 4, but I'm going to go through position 3. So I'm going from 1 to 3. So let's try that. So I'll go back to 1. Let's see if it misses. Oh yeah, look at that. Beauty. Woohoo! Where's my bell? So it worked. So now we want to put it on the ground, put it back on the table, which is position 5. Position 5. Sweet, let's put it down. Run a single line. Okay. So let ourselves get back. But you know what? We need to do one more position. In order for us to get back, we got to create a position 8. Because position 8 is that new position, but in reverse. So before we get too much farther, let's go do this number 8, because the 8 should have the same numbers as our position 3. So let's do this. Let's go get position 3. Well, that's the position that's out there. And we'd also want to have that as position 8. Because we need to target, well, maybe we don't. Let's try it once. Let's see what happens. Maybe we just need to target our, back to our position. We just want it to go through position 3. Let's do that. So at this point, let's open the grip. Single line. Yep. So let's get back to 4. And now we got to get back over to position 1. So let's grab our go circle. So our target now is position 1, and we want to go through number 3. Through the go circle. So let's try that. Let's open the grip. See if it goes from 4 back to position 1 through that. So let's do a single cycle. So there it is. Look at that. So we're back now. So that's your go circle. So notice that it doesn't stop at that intermediate point. We have some test questions that are about that. So let's go ahead and take a look. And finish it off. So we now need to get the red cylinder over there. So the red cylinder is at number 6. Let's grab number 6. We have to close the grip. So let's do that one. So there's 6. Close the grip. We need it to go back to position 1, which is our overhead position. Let's watch that happen. Position 1. Now we got to use our go circle. So our go circle is to get to position 4. And we want to go use that position 3 again. So let's watch that happen. So we're going to go from 1 through 4 to 3. There you go. Look at that. Beauty. Set it down. Position 7 is where the new red cube goes. Let's go to position 7 through a single line. Let's open the grip. Boop. Back to 4, which is our lift up. Remember, now we don't want to take off and go home just yet. We need to get up out of the cell. So that would be number 4. And now we could go back home because the exercise is complete. So let's go to 99 and close the grip. So let's try it. So open the grip, go to 499 and then complete it. So let's do a single cycle from that. Oh, nice. It missed our stack. And there you have it. Complete, complete, complete. Sweet. So there you have it. Well, let's go back, reset the cell, and I moved all this jockeying around for nothing. So let's go ahead and take a look at it. See if I can get in closer so you can see everything. Zoom in. So let's watch this happen. So let's put the blue line at the top. I reset the cell. Let's watch it one time through. So there you have it, ladies and gentlemen. Complete. That's the go circle. Thanks for watching. We'll go on to the next one. Hey, welcome everybody back to our robotics series. This is a series of presentations that we have built around the Intelitek ER4U robot. We are developing a series that will help you understand how to program and work with the Intelitek robot. I guess they used the word ScorBOT. I just reached around and looked at the machine. So this is robot number 8. We finished off robot number 7 with talking about loops and remarks, and we're going to use the same strategy here. A loop is a mathematical calculation so that the robot then can use limited number of moves, but could move thousands of parts given a, let's say, a flywheel from an engine, and it has to go through a number of machining processes. Rather than writing a specific code for each one of the parts, we can write a loop that will do thousands of parts with very few programming processes and create a mathematical formula that when it reaches a certain limit, then the robot then would stop and then put itself away. So let's go ahead and get started. We start with our cell setup, and today we're going to add a few more pieces, starting with new. Remember then that when we use the roller ball, that we can tilt the manufacturing floor both back and forth like this, and if I push the right mouse button down, I can move it from rotate in, and I can zoom. The new object list always pops up. If you happen to lose it, it can be gotten back from the cell setup toolbar under new objects, and you can repeat that as many times as it's necessary. So let's go get the robot. When you pick OK, you have a choice of no slide base or a slide base, which would be a 1 meter long. These are the ones that we have here in school, are all the 1 meter ones, but we're not in any hurry to, we have no slide base for these operations. So the first thing we're going to do then is put the robot out there. Okay, next, we want to slide a table underneath that. Under General, you'll find the table. You can change the color of the tabletop. I always suggest, though, that you try to keep it in the lighter color ones, so that if you use a dark color, then sometimes the cubes disappear. Let's kind of use that sky blue. Please leave the tabletop the size that it is. Now put it somewhere on the construction floor, on the factory floor, and then we'll take the hand and then we'll grab it and place it just like this. I always like to keep the robot to the back of the table, so I have all this real estate to be able to put parts out in front. So we're going to use 4 cubes today. We're going to stack them up over on the side, and we're going to give the cubes a position of a 250, negative 260. So that'll put it to the left side of the robot. So again, when we use these cubes, be sure that you use extremely different colors with them. If you try to put all red, when we stack them, they all have a tendency to fall into one another. Doesn't matter what material you use, I just leave it at plastic, and then the 40 millimeter by 40 by 40. Don't change those sizes because our lab exercises are set up for the 40 by, and that's actually the size cubes that we use with the real robot. So we'll want to make sure that you use that, and then we'll place it down on the table. Be sure to set it on the tabletop. If you set it anywhere else, it kind of locks it in at the height, and you're not going to be able to put it back on the table. So the only way you can drag it is from side to side. You can't go up and down. Double snap on that cube. You have 3 things you can do with it. You can rename, rotate, and position it. So we're going to rotate that to be 45 so that we can grab the cube on the side rather than on the corners. And then in the position that we're going to use, the cubes are at 250 for the X and negative 260 for the Y. All right, so we're going to stack 4 top of one another. Again, use extremely different colors. Doesn't matter which colors you use. Rotate to 45. Now we can rotate the cubes, or we could rotate the claw arm if we need be. Just easiest right now. 250, negative 260. Teach. Let's go ahead and do how about this brown? Put that arrow right on top of the next one. Position 250, negative 260. And then the last one, we could use, let's say, a yellow. rotate 45. $250, negative 260. Okay, so those are the cubes that we're going to use. Now, we're going to put some storage bins out there. We're going to use 3 storage bins. Storage bins are under storage devices. So we're going to have a bin. Now, there's not much choice in a bin. Put 3 of them on the table and then we'll line them up. The bins as well can be positioned as the 3 choices we have. We're going to leave them straight as they are, but we will find a position for them. Bin number 1 is at 250, negative 80. Bin number 2 is at 250, 100. And the last bin number 3, is at 250. And the Y is 280. Okay. So we are going to use 3 of the cubes. We're going to place them in each one of the bin. And as then we fill the bins up, we're going to say then, oops, we're all done with our programming. Our bins are full. The robot then needs to make a decision and then go back to its home position. But we are going to use our loop control then to create as short a possible programming as possible, and we could use a never-ending stack of cubes and bins if we choose to. So, want to save this. So let's go save as. Let's save it to the desktop. Up, desktop. Make sure you double click on that. And then we'll call this robot number 8. Okay. All right, so let's go to our Robocell and let's start a new program. Whenever you start a new program, a couple things you need to do. Number 1 is make sure that you move the L1 to Pro, because we are professionals. That gives us a better list of things that we can work with and more opportunities. And then the other thing is that we immediately want to go ahead and program our home position. Our home position then is 1300330. It's a good idea to memorize these. Negative 90, and the number in itself is 99. Here you must hit the teach button in order to record it. So let's go ahead and get the robot. So under File, Import. Now wherever you've saved it, I've been saving it to the desktop so I can easily retrieve it. There's my robot number 8. And then here's what we have that we just did. Now again, I recommend that you not close it out. Make sure that you leave it up on the screen so that if there's a mistake, we can quickly go back to it. We've imported it. Let's just move it around. Some of the same commands that we had before, that the roller ball and right mouse button do the same thing. Let's hit our teach command. Let's put add that 99 to our list. Open the grip. Let's see if it works. Now again, let's just go over how we make the robot move. On the toolbar across the top, we can move it a single line at a time. We have a single cycle, and then we can do continuous. Next, under the Run command, this menu, we have single line, single cycle, continuous, and then we have the word stop. You can also use the F keys, F6, 7, and 8 respectively, and then the stop button would be the F9. We also have this big red stop button which works right here. So those are the pieces that we have. So let's see, let's do a single cycle. Let's put the blue line at the top and then hit the single cycle, and let's see if we can get it to go home. And open the grip. Yeah, baby, that's what we got. So we know the two are connected. Also, under the option command, you just want to make sure that the check mark, and I forgot to say this in a couple of the videos, that it's under simulation. If we were to try to click it online, that actually moves the control from the simulator to the real robot, which is hooked up through a USB cable into the back. So we want to make sure that we're always on the simulator. All right, next. So let's go down and add some programming. Our cubes are going to be positions 1, 2, 3, 4, and they're set at a position of 250, negative 260. The only thing that we have to change is the Z command on how high they are. So if we choose to start with our bottom cube, call that position number 1. $250 for X. Y would be negative 260. Our Z would be 17.5. The negative 90 and 0, and make sure you hit teach. Now our second position, number 2, would be our red cube. These X and Y can remain the same, but I have to grab it just a little higher. And since they're 40 millimeters apart, you add 40 to 17.5 and you end up with 57.5. Hit teach. Number 3 is the brown cube. X and Y remain the same. We just have to reach a little higher, and that would be 97.5. And teach. And then position 4 then would be, if you add the 97 plus 40, you end up with 137.5. All right, 1, 2, 3, 4. Red, blue, brown, yellow. And then a position that would be over the top of that, we can add, we can create any number that we would like. So let's just call it position 100 so that it doesn't interfere with any of our mathematical formulas. So we can make that position 100 over the top, and then that would be, let's call it 200. That gives us over the top of this, above that stack, and teach. So we have the 1, 2, 3, 4, and then the number 5th position then would be above that, and that we call that position 100. Now let's add positions over each of the bins, and I have those written down as positions 5, 7, and 9. Our Z coordinate will still be all of the 200, so they'll be over the top. So our first position would be number 5. So where did we put the first bin? The first bin is at 250, negative 80. It's at the 200 level, and we'll teach. Bin number, over bin number, the next bin would be number 7. Bin number 2, 250, 100. And then we'll leave it at that. Leave it over above. And our next over above is number 9. And that Y would change to 280. And we'll leave it at the 200. All right. So let's get in the bin below. So number 6 and 5 are related. So the bin number 1, 250, 180. Now we're going to change this a little bit. Now the bottom, the bin itself has a little thickness. So if we leave this at the 17.5, we're going to have impact because the bin has got a bottom to it. So let's just use 23. Now the cube will drop just a little bit, but not bad. And by putting 23, then we make up for the distance that the bin bottom has, and we won't end up with the impact. So, and now 7 and 8 are related. Again with over bin number 2. So the 250, 100, and the 23, and the last one then, even number 10. Change our Y to 280. Everything else remains the same. And then hit teach. So this is then, bin number 1 is associated with position 5 and 6. Bin number 2 is associated with 7 and 8. And bin number 3 is associated to 9 and 10. Well, that really is all the ones that we need. So then we should have, when we look under here, we should have 1 through 10, plus this 100 one, which would be over the stack, and also then 99, which is our home. So we'll need to make 3 changes. You know, when we look at our system, we need to assign names to our first position, our first cube. We'll need to make, with our first drop, and then we need to make a name for our first bin. So let's go ahead and do that. We'll do that right away before we get started. And those then would be all setting variables. SV. Now I move the picture, the import over here on the other side. If I leave it here, it'll disappear. And I'll probably lose it at some point or another. I'll make a mistake. It's just a matter of going and getting the image and put it back on again. So let's do our first one for home, and we're going to call that position 99. We already have that 99 we've already used, but we can either say 99 or we can say home. Our next one then is pick, which relates to the stack of cubes, and the top cube is number 4. Our first drop is associated with bin number 1, and that is number 5. And our first bin is number 6. Well, there you have it. So we've created some words for some of the positions that we wrote. So home is 99, our first pick position, which would be our cube. Now you could use, instead of using the word pick, you could use the word cube. Might be more advantageous. You know, all you have to do is double snap on it, and if you don't like the word pick, you could say, okay, well, that's the cube, the first cube that we got. So cube with position number 4. We could use that, I guess. Cube. Doesn't matter what word you use, as long as you write it correctly. All right, so we're going to go drop over a given bin, and then our bin, our first bin, is position number 6. The second bin is position number 8. And the third bin is position number 10. But we're really going to be concerned, though, is about our cube. So we'll write the formula based on the word cube. All right, well, let's do some basic programming here then. So the first place that we're going to want to move is to position over 100, because that's where we want the cube to go, or I should say the robot to go, to be able to first pick up the first cube. All right. Now, you better run this from the top, though, because then it will engage all of these words, because we want to start using these words right away. So let me just recycle this. Start from the top, so that all of these words then will be engaged. There we have it. So now we want the robot to grab that first cube. So instead of pulling up position 4, what I can write is the word cube, because we've asked cube now to be number 4. So if I use that and do a single line, notice that it's going to go right to the top and grab the yellow cube. So I want it to close the grip. Yep, that's a good plan. So I'm going to force it to close the grip. So let me do a single. Boom. Now we want to go back to position 100. You always want to be up in and out of the cells safely. Single line. And where do we want it to go first? We want it to go over the first drop. So let's have it move to drop. Now we could write number 5, but let's go ahead and use the word drop. And have it go, and I guess, and see, there you go, right over that first bin. And now we want to put it down, so let's put it in the bin. That would be position 6. But since we already have a name for it, let's call it bin. And we'll put it down as a single line. Okay, very good. Oop, and see, now I did have impact. So I need to go back and adjust my position number 6. So I need to get the numbers for position 6. And there they are. So it looks like 23 had some impact. So let's go to 20, I don't know. I know 27, it won't smash into it. Now remember to teach it. And I better change, let's get the numbers for position 8. Change that to 28. 27, guess what we're using, and let's get the numbers for number 10. I'll get those numbers. Now we can change it then to 27, and then the most important thing then is to teach. So there you go. So that's how you would adapt on the fly. So let's just make sure that that happened. Get those numbers, yup. And yup, and the last one, yup, okay. So that should work. So let's just try this. Let's go back up. Back down. And you see we don't have impact. Okay, we want to let that thing go. So we want to leave it there. So we want to open the grip. So let's have that happen. Single line. We want to move back now to the drop position, which was number 5. We called it number 5. Let's have it go back up. And then we could have it swing over to position 100 again. Now, before we do that, at this point then, let's start adding our, let's have it run through all of the reposition numbers before we send it over to 100, because it's going to go back to 100, because right now we want it to go back to the top, and to get it to do that, we want to start a loop. And our loop is called a label, so we can put that label up there, and eventually, as soon as I get done with all the calculations, well, I'll tell you what, let's add those calculations first. Okay, so right here then, let's add this variable. So now to our to our cube one, so we want from 4, we want to go to 3. So we want to go to position 3. So then cube is -1. So that would change it to 3. We want our drop to go to the next bin, which would be a +2 kind of situation. So we want to have drop +2 and 6, 8, 10. So we need then our bin to be bin +2 as well. So after we go through this, cube is no longer position 4, it's 4 minus 1, so it'll be 3. Our bin was 5, so now it'll be 5 plus 2, and now it'll be position 7. And our bin was position 8, so, or I should say it was 6, now 6 plus 2 now will be 8. Next time through it does it again, so -1 it would be 2, plus 2 would be 10, plus 2, or I'm sorry, plus 2 would be 9, plus 2 would be 10. But now we want it to jump back to the top. So then let's say jump to loop. So let's give it a name. So after it gets all this through, we want it to jump back to the top. So we'll use the word loop. So we need to put it right here. And LA is that label, loop. So when you put the blue line here, when you add this, then it just inserts it and pushes everything down. So this is the loop that has occurred that will continue to move to all 3 of the bins. And we did it only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 commands. And we could move hundreds and hundreds of cubes. The other thing, though, is right here, we need to make it a decision, though, to make sure that there isn't a situation that we've ran out of bins or that we've run out of cubes. So we want to actually put an if jump there. So we need to consider that we don't want that third cube to go there, so we don't ever want it to go and grab position 1. So we want to say then that if cube is ever less than 2, if the calculation comes up that if it's ever less than 2, we want it to jump to the end. So we want to have it stop the program. We want it to go to the end. So if this number, if the cube is ever less than 2, now if it's at 2, 2 is not less than 2. So that makes this false, so it'll continue to jump back to the top. But if it is complete, and we do have now where it's gone through the formula and says now cube is 1, 1 is less than 2, we want it to jump to the end, so let's put that label right there. And what do we want to happen? LA. What do we want to happen at the end of the program? Well, we want it to go home, which we put 99, and we want it to close the grip. I'll tell you what, we put our labeling on steroids. We only did one for position robot number 7. We only did one calculation like this. Now we've added 3 separate calculations with the using the cube, so we've kind of done it up on steroids. But this is the easiest and most efficient way to do it, to be able to come back and to do all 3 cubes, and then once it's done, 3 of the cubes filled up the bins, we want it to return back to the home position. So let's go ahead and restart this. Let's put this up here in the left hand corner. We can grab the robot and have it start right from the beginning. I'm going to put the blue line at the top, and let's see if we can get this thing run correctly. So what we're hoping to have happen is that cube number 4, we've called it number 4, we'll get into the first bin, which we called it position 6, and it went over the top at position 5. Now when it gets to the bottom, now we're looking for cube number 3 because we minus 1, and now we're at the second bin, which should be 6 plus 2 would be number 8, and over the top of it, it's 5 plus 2 would be 7, so 7 and 8. But cube 3 this is false. Cube 3 is not less than 2. So if this is false, goes to loop, jumps to the top. So now, looking for our next time through. Next time through then, bin then gets turned into position 10 plus 2. Our drop gets 2, turns into 9. And then it gets back here and turns from cube 3 minus 2, and then it will drop it over here. So at the very last one though, even though it is programmed itself for a 4th bin, it does say though that 2 minus 1 is 1, so 1 is less than 2, so you're going to jump to the end and then put yourself away. So with any luck, this should work. So we really went from robot number 7 to 8. We've really done our labeling on steroids. So let's see what happens. Take it from the top. All right, let's open the grip. Position 100. Get a cube. That cube was position 4. Drop to 5, drop to 6. Open grip. Then it comes back out. All right, so everything changed. Cube 3. Now positions 7 and 8. And notice then that we changed our drop a little bit so that we wouldn't have impact. Here we go. So now we're at cube 2. Drop went to 9. Bin went to position 10. Comes back out. Now watch it run through. And now it says, yeah, there it is. So it did figure it out. So cube turned into 1. 1 is less than 2. The robot put itself away. Ladies and gentlemen, we've completed the exercise. Hey, it did it. So, and we've completed those cubes, in less than 25 moves to run the whole process. This could have been, we could have had 4 bins. We could have had 10, 12, 18 bins. We could have stacked these cubes up as high as we wanted. And as long as we had the position set up, this robot would continue to move cubes into the appropriate bins. And then when this last statement, when it got to number 1, number 1 is truly less than 2. So let's jump to the end and put ourselves away. So there you have it, ladies and gentlemen. We went with our remarks. Remember that we're asking at any point we can write something on here, and with that remark, the robot doesn't read that in its programming, but it's nice for the as we look at it as a programmer, and I just like them in all caps. There you have it. At any given time, you could we could put remarks here at the beginning where we could label it. Let's just say, let's call it loops and remarks. Remember that the controller doesn't read these numbers, doesn't read these words when we use it as remarks. So they're oblivious, or the robot is blind to them, and it just helps the reader then to understand what they're seeing. So, hey, thanks for coming. This is our robot number 8 in our series. Hey, welcome back to our video series. We are creating different projects, different samples of work for the ER4U robot from Intelitek. This video series is a series of lessons that we do here in class. It explores different options and different things that you can do with the robot. Today we're going to add a pneumatic feeder, and to show you how the simulator actually works with the pneumatic feeder. The real life pneumatic feeder requires that you turn the inputs on and off. We need to do the same thing with this one. As you would turn the pneumatic feeder on, it would push out a pneumatic piston, which would put a cube out in a place where the robot can reach it. Then by turning it off, then the piston retracts and then reloads with another cube. So that's similar to what we want to do today, although the simulator facsimile of the pneumatic feeder doesn't look anything like the real one. But we'll go ahead and use it today anyway. So let's start a new program, and this would be robot number 9 in our series. As we have talked about before, use the roller ball to roll back and forth. When you push the right mouse button down, you can zoom and rotate. So those are the 3 ways that you have control. You also have a hand that you can use to move around, to move it up and down in the position as you roll back and forth. So the other hand control we use to drag objects, and we'll show you that in just a minute. So the new object list is here. If you lose it by any chance, it's up here in the corner of our cell setup toolbar. You can bring it back, and then sometimes you lose it, so then it's easy enough to bring it back. So our robot, our E4 is the only one listed, so when you double snap, you have your choice of slide base, no slide base. For most of these at this point, we won't use the slide base, and it kind of puts it out in the middle of nowhere. Under the general, then you can have a table. So our table top can be done with different colors. I am feeling a little blue today, so let's put a blue one out there. Now you can put anywhere on the floor. Here's your object. You drag, so drag your object underneath there. I always like to put the robot to the back side of the table, so I have all this real estate out here to work with. And then under storage devices, you will find the feeder. Now when you double snap on it, you have two things you have to do. We have to load it up. So we're going to load it up with 3 cubes today. And, oh, not done yet. Oh man. So I don't know if I can get these things back on there. Let's see once. Here's our feeder. Okay, so I was able to get it back. So under, how did I get it? I snapped it out here too quickly. Under control setup, here's our feeder. So we don't need inputs. We want to, we could slide it up under number 2, but actually the output we want, we're going to use that a lot, so we want to put it at number 1. So you still can, even if you close it out too quickly like I did, you still can get the control back, and then make sure you hit apply. And you'll notice then that it still gives us the ability, and we already have the 3 cubes. All right, so the first thing we want to do is let's rotate it so that the end is sticking towards the robot, and -90 will do that for us. And then we also want to position. So let's position it out at a 45-degree angle from the robot. So 250 for the X, 250 for the Y, and then there it is. Now, it seems though that we got to load it up with a cube right here on the pad before we go away. So under our materials, we need to put a cube out there. Now, depending on what color cube you put, it just will automatically add. It's not like you can put a red one and a blue one and a yellow one in there. Whichever you pick for the first cube, those are the ones that will pick. They'll all come out red, or they'll all come out blue. Now, in the real pneumatic feeder, obviously we can load it up with plastic, wood, different colored. We can do red, blue, yellow. But once we put a red cube on there, which we will do, and you have to put it right on this pad, right there, and load it up ahead of time. That seems the way the simulator works. Let's put it at the same position, 250, 250. And there it is, centered up on that spot. So this is the way we have to set it up. So now we can save it, and save it to the desktop. That's a nice place where you can find it quickly in case you make a mistake. Desktop, let's save it as robot number 9. So we've done this 3-4 times already today. So yes, let's replace it with number 9, and there you have it. So that's what you need to start. So let's go to Robocell now and start the program. So file new. So a couple things you got to do. Remember to switch it over to Pro, because we are professionals. We expand. And now let's add our home position. Please remember these numbers. 130 for X, our Y is 0, the Z is 330. The pitch is -90, and the roll stays at 0. Remember the most important piece, hit teach, otherwise it won't record. All right, so let's bring our image in then. So let's import under the file. Let's find robot number 9. There it is. Now you notice that red cube disappeared. That just seems to be the way the simulator works. But if we didn't put it on there to begin with, we would not be able to get the robot to function and then to start grabbing it right away. So we discovered that over a couple, 3 years of trying to get it to work. So there you have it. So let's put in position number 99 and let's open the grip. So let's do blue line at the top. Let's do a single cycle and let's see if it moves. So yep, it's connected. And if you're worried about being connected, under the option button, you see that we have the check mark placed at the simulator. If we were to try to connect with the real robot, we'd want to use the on. Try to click it to on to see if it would actually work to that. If we click on hardware setup, we don't really, right now we're not working with the slide base or the rotary table, so we're not worried about that. But we are working now with a gravity feeder, which we have to turn on and off. So let's get over to a position number 99 where we're going to grab that cube. Let's go from the 99 position over to position 1, and then we'll have position 2 where it's actually going to reach down and grab the cube. So let's create a position 1. So we want to get over the top of that pad, 250, 250, and let's call it 200. So we don't have to reach up too high, and then teach. Now our position 2 will be the same position, but we're discovered that this little pad here on the on this pneumatic feeder has some thickness. So we have to add about 40 millimeters to our 17.5. So let's just round it up to 57. And then as we come down to grab it, we actually have to turn it at 45 degrees so we can grab it on the flat side. So here's going to be the way we're going to do it. So let's put position 1 in there. So let's send it to position 1 by doing a single line. Now let's turn our feeder on and off. So let me move my picture to this side and input on would be number 1. And before we forget, let's just go ahead and turn it off right away so we can energize it to open and close. And then we can go to position 2, grab the cube when it pops up, close the grip, and then go back to position 1. So let's see if that works. Now, since we're going to do this 3 times, you're going to see that I can cut and paste this grouping right here each and every time just to be able to grab the cube. And then we'll move it to 3 different positions out here. Cube 1, the first one is going to end up at 250, negative 250. The second cube out of the chute will end up at 250, negative 80. And the third one will end up at 40, 400, and the Y will be 0. So that we'll need to make above positions for each one of those, and then we'll be done. So let's just see if this works. So I'm at position 1 right now. So let's run the single cycle. Ah, there it went. Pop up on a feeder, we grab it, went back to number 1. So that does work. So we're going to copy. I can copy this from line 3 to line 4. I can right click on it and I'm going to copy. So let's just leave that into the copy base for now. So let's add some new positions. I'm just going to go through right now and I'm going to take a little bit of time to record positions 3, 5, and 7, and 4, 6, and 8. I have my teaching positions already filled out. So I'm just going to use the chart to do that, starting with position 3. So position 3 is 250, negative 250, 200, and we can turn that back to 0 and teach. We want to set it down on the table, number 4. So number 4 is 250, negative 250. And we're going to push it off, and just set it down on the table just a little bit higher this time so we don't have impact, and teach. Number 5, position number 5, 250, negative 80. Now my worksheet actually says 300 for the Z, but we can narrow it down so it goes a little quicker. We can put to 200, but the actual worksheet says 300. Now let's do 6. So 6 is related to this. Let's do 25. Let's do 7. Position 7. Notice how I keep hitting the teach button. Position 7 is 400, 0, 200, and teach. Position 8 is the same. It's right underneath this one. So we'll just switch this to 25 and teach. So let's see what we got. So 1 through 8, yep, that's what we want. And position number 99. So there you have it. So now if I wanted to get any given position, let's say I made a mistake on position 4. I put the number there, and then I can hit the words get position, and then it gives you what you recorded in position number 4. So if you had to make a change, you wanted to change anything, change the number, and then again, remember to hit teach. So let's go back to our diagram now. Switch papers. So now we want this cube to go to number 3 and then number 4. So let's do the straight line. So we want it to go to position 3, then position 4, and then we want it to open the grip. So let's see if we can get it to do that. So let's see, 3 and 4, run a cycle, 3, 4, open grip. Beauty. Let's go back to 3. Single line. Okay. So now I can hit my paste button now and have it go back to 1, on and off, to position 2, close the grip, go back to 1. Let's see if it does that. So run a single cycle. So when you have positions that you repeat, there it is. Now we could actually create a loop where we would have a mathematical formula rather than continuing to add to this list, because we're going to run through this 2 more times. So now we want to go to position 5. The diagram says 5 to 6. Now I want to open the grip. See here, kind of the same thing. We're going to open the grip because I want to leave it there. And then I want to go back to position 5, because remember the safety factor is you always kind of want to come up and down out of the cell in a straight line. So it's at 1. Let's start it right here. Single cycle. Let's have it to go 5 and 6. Open a grip. Sweet. All right. Cut and paste time. Paste. Let's run the cycle. 7 and 8. So 7. Move it to 8 where it sets it on the table. Okay. Open grip. Back to 7. Alright, so do we really need to go get another cube? Nope, we're done. So let's just send it home. Send it to 99. And good housekeeping, let's close the grip. So let's try that. So let's see, it started at 7. Run the cycle. Nice. Looking good. So let's do this. Let's reset the cell. Let's see if it can run through one time. Zoom in some. Put the blue line at the top. Now let's run a single cycle. Run it all the way through from the top. Should have a little music. Should I hum? Should I whistle? Oop, there it comes on, reaches down. Notice then that the jaws grab it on the sides because we have that set up at a 45-degree angle. Now we're going to put it at the first position, 250, negative 250. Open grip. Now, bears back to 3, so now we repeat the cycle that we pasted in there. 1, on, off, 2, back to 1. Now we're going to go to position where cube number 2 has to go. And that would be 250, negative 80. Still, you can see that's on the left to center for our robot. Left of center because that's a negative Y. And now let's have it get the last one. On and off, there it is. Now we've loaded it up with 3 cubes, even though we might even want to try for a next time to try to get another cube out of it. We won't. So we might as well just call it a day, head back home. Close the grip. Bag it. Boom. So there you have it, ladies and gentlemen. That's our pneumatic feeder. This is the end of Robot 9. So we'll see you next time. Hey, welcome back to our series on the ER4U robot from Intelitek. This exercise is about creating a loop. The loop, or LA, when writing long and repetitive programs, the loop can save you time and coding. Positions can then have numbers or names that are set up by the set variable command. Today we'll use a stack of cubes, more cylinders, and be able to pull 3 out of the 4 off the stack, and when it gets to finish the third item that it's supposed to move, we'll want to have itself have the robot put itself away. We've done this before, so this should be a review of the loop. And then we'll use the remarks then to show you how to do that. We'll just basically call out the exercise, and we can put our name at the end, and we'll go through the process of printing. So let's go ahead and get started. We want to start new. As we start new, remember that on the factory floor we can roll back and forth with our thumb wheel, and then if I hold the right mouse button down, I can zoom and rotate. So this is something that we should be familiar with by now. All right, the robot is up here in the corner. Pick no slide base, and then put it out on the floor. Underneath that, let's go ahead and put a table. Remember, as I said, we can change the color of the tabletop. Let's choose yellow today. And we can use the item drag. I typically like to put the robot in the back middle of the table so that I have all this real estate out here to be able to move my and operate the exercise today. If you lose this screen, that's okay. Don't panic, because it's right under here under the new object file, and then we can bring it back. All right, our material list is, let's go ahead and grab cylinders today. So we're going to stack 4 of them up, and we're going to unstack these today. So let's start that first one. And when you snap on any object, you can rename it and reposition it. With cylinders, there's no need to actually turn it at any angle. So it makes our programming just a little bit easier. So today we're going to stack all these at 250, negative 250. And now let's put three more on top of that. Now remember, when you're stacking cylinders or cubes, remember we want them to be colored with drastically different colors, because if they're close to that same color, they end up falling in on one another, and we don't want that. Next, let's go get a different color. I'm going to stay away from yellow today because I've got a yellow table. Let's do, how about this brown? Put that on top. 250, negative 250. And remember, you have to stack them right away. Otherwise, once you stack them on the table, they can't get stacked on top of one another. They actually have to be done as you place them on the table, then, so that they have that different look to them. So we could use this light blue now. And 250, negative 250. Okay. So that's all we need. Once we get over to the program, we can take a look at that and add it. We'll import it. So the next thing to do then is to save it as, and my recommendation is always save it to the desktop, because then it's a little easier to retrieve. And we'll call this out as robot number 10 in our series. And then we'll go ahead and open up Robocell. All right, so let's jump into Robocell. Remember that when we open it new, a couple things we have to do right off the bat. And that is, remember to switch it over to Pro, because we are professionals, and that gives us the ability to do a lot of different things with this that we can't do in the L1 category. Next, let's go ahead and expand, and let's create our home position right away. Home number 99. 1300330, negative 90, and roll 0, teach. Okay, let's bring that robot in. So we want to bring in the 3D model, and since it's saved on the desktop. It's real easy to bring it in. So there it was. There's what we've created up to this point. Oh, darn. Where'd it go? There we go. I don't know why that disappeared on me. Use the hand. Want to get close up here. So there it is. So if we put our position number 99 in here, and then open the grip, put the blue line at the top, do this just like we've done before, then run the single cycle so that we can get the two commands to work. There we go to our home position, and booyah. The claw opens. There you have it. So now we can go ahead and start our programming. So in the handout that I have, we want to right away now create some of these variables. And one of the easiest ones, now I don't have it on the worksheet, but remember that when we're setting these variables, we can create names for these. So let me move this to this over here so that I don't lose it as I open this program up. So SV is where I want to create some variables. So let's do one of them, and let's call this one home. This is pretty common, home, and we'll call it position 99. Next, we have to create, we're going to call pick, which would mean then that we're going to go ahead and grab the cube, and our position number 1 is going to be right there at the first cube. So let's go ahead then and pick, and let's make it position number 1, because our cubes are going to be position 1, 2, 3, and 4 starting from the top. So starting with that black, light blue one, turquoise would be position 1, 2, 3, 4. So then let's do our drop position, and the drop then will be 10, 11, and 12. So the first drop position we want to start with. Now drop means that we're going to set it on the table. We're going to create that as position number 10. So those would be the things then that when the robot immediately starts up from the home position, it would start out by giving you the home position, or which would be 99, grip, open the grip, and then it sets these values, and then we'd be ready to run the program. So as we have done before, since this is where we want the program to jump to every time, we know then that this should be where our loop label is. So a label is LA, and we're going to call this loop. So this is where we want the program to jump back to. So later on then, way down on the end of the program, then we're going to give you the word jump to loop as we create this for our positions. Now, let's go ahead now and let's record some positions, because we have positions 1, 2, 3, 4. Then we're going to go position, we're going to skip a few so that we don't interfere with our adding and subtracting when we go through these things. We're going to do a position 8, 9, 10, 11, 12. So we're going to skip 6 and 7, actually 5, 6, and 7, just so that we don't get a robot then that's trying to place cubes in a position that we really don't have any place for it to go. So let me just start with position number 1. Okay, according to my worksheet, position number 1 is 250. negative 250. And since the first one on the stack of 4, remember that if I continue to add 17.5, and if I get that to the 4th position, that's the number of 137. Position 2 is the next cube down. The only thing I have to change then is minus 14.5 away from that one, which gives me 17.5 or 97.5. Let's now go to position 3. And now it is 57.5. Teach. Make sure we're hitting that teach button every time. Let me just make sure that I did that. Yep, that's right. Okay, so let me go back, and number 3 then. Position number 3 should be the 57. Yeah, okay, good. Position 2 would be 97, and then position 1. All right, we're all good. Okay, let's go down to position number 4 is I think where we're at, so we need to change this, and position 4 is at the table. We don't necessarily need this one because we're not going to move it, but maybe, you know, at some point maybe we can figure out what to do with it. But position 4, or that last cube that's at the table, which looks like the red one, we're not going to move that one at all, so we're going to just leave that on the table, and then we're going to move the top 3. Okay, so we're going to use a position 8, which is way above the stack, and position 8 will be our 300, so that'll be way, way up at the top. Now let's create a position 9. Create a position 9, which will be a new position to take all these cubes, and we'll call it 350, 0, and the height of that will be the 300. Teach, and now we're going to look at position 10, 11, 12, which are going to be on the table. Now remember that position 10 we call drop. So position 10 is going to be 250, negative 100. And since it's at the table, 17.5. We don't need to change the pitch or the roll. Teach that. Position 11 is 400, 0. 17.5. And position 12, 350. Whoop. 350. 80. Yeah, I don't know. I don't know why I got these random, but it really doesn't make any difference where we're putting these things. Okay, so there you have it. So now from the diagram, you're going to know that we're going to put out here. We're going to put the 3 top cubes: turquoise, the brown, and the blue. Turquoise, brown, and the blue. We're going to set them down here one at a time. And each time we're going to go back to our position 8, and then that is where we'll actually make the decision on our creation of the loop, so that when it gets to that position, it's going to think about what it needs to do and then go from there. All right, so let's start adding to the program. We have all of these positions are all set. So let's go ahead and number 8 is over the stack. So we have our gripper open. So let's put number 8 on the list. And we want to move it over to number 8. So let's drive it over there with that single line. not single cycle, but single line. Okay, and now we want to set it to the pick position, in which we've called out number 1. So let's call it out as pick, because we've already made that decision for the robot, and we've asked it to set that variable as pick equals number 1, so we wanted to go to pick. And let's see if it really indeed does that. Oops. I didn't, okay. Can't do that yet because I actually haven't run that program from that position. So here, what I'm going to do is this is going to run it. Cycle, okay, so now I got it. All right, so now I got the pick position. Now let's close the grip. And then let's put it back to number 8. Number 8 is where I want to go with it. Let's run it to number 8. Single line. Remember that the movement of the robot, single line, single cycle, and then continuous can be picked off the toolbar. Also under the run menu, you have the single line, single cycle, and continuous, or you can hit the F keys, 6, 7, and 8. Then there's our stop button in case we want to stop quickly. You can either hit the stop button here off the run menu or hit F9, or there's a big picture of the stop button over here. So those are the 3 ways that you can actually get the robot to run. Have been going through that every exercise that we talk about. So now we want to get over here to position 9. Position 9 is a position up over the table. And let's run that. So clickety click. Go put it over there for me. And then we want our first drop position. So let's add drop, and since we've already called drop out as position 10, should set it up on the table. Let's run that single line, and voila, there it goes. Bingo. Let's open the grip. Make that happen, and now let's send it back to position number 9. And then that will come back to the center. Now, I guess we can use this one. Right here now we should update our, go ahead and run our, create our mathematical formula right now. And adding, in our pick situation, we're going to add 1. In our drop situation, we're going to add 1. So let's go ahead and do that. And then at the end of that run, sitting right here, then we can actually have it make the decision. Rather than jumping over there and getting, one more position, let's just leave it right here and let's just call out our formulas. So what do we want to do? Okay, so our set variable. So with pick, we have position 1, 2, 3, 4, which would actually move down the stack. So we want pick to be set as pick plus 1. So there's pick plus 1. We want our drop now to be drop plus 1 because we want it now to go to position 11. So drop plus 1. Okay, so here now pick plus 1 would be 2. drop plus 1. Well, this would be 10 plus 1. That would be 11. But we want now to make sure that our pick doesn't exceed number 3. So we got to run a formula so that this is here's our if jump. So if pick is greater than 3, so which one is the greater one? I think that is greater than 3. We want it to jump to the end. So right now it's 1. So 1 is not greater than 3. Gets to the second round. Is 2 greater than 3? That's false, so it gets to the third round. Is 3 greater than 3? No. So it gets to the fourth round, and then rather than coming down and grabbing that fourth cube, what it's going to see then is is 4 greater than 3? Yep. So then we want it to jump to the end, and then we'll put that position out here. But if this is false, we still got to get it to jump up to the top and jump in here to our loop so it can go back and grab the next cube down and the next cube down and the next cube down. So we want to, where's our jump to, there it is, our jump to loop. So that when that command is false, we want it to jump back to the top. But if that command is true, then we want it to jump to the end. And what do we want at the end? We want it to go home and close your grip. So that's all there is to it. We could have 69 cubes set up here, and maybe we do that someday. But we can control it all only using 21 lines of code. Here, remark command. You can put your name. Remember that using remarks does not cause the robot any difference in its programming. Put that there, maybe at the top. We call this out as, let's see, once, robot 10, loops and remarks. So there you go. Remember that it doesn't read this, and it won't read my name. So that's it. So let's take it from that number 9 position. Let's move this over. And that should get it. So let's run now. Remember that we don't need to run a continuous. Because we've created our loops, it will run continuously by itself until this statement here on line 18 is true. So if pick then becomes greater than 3, then we want it to jump to the end and then put itself away. So it will, from number 9, once it gets through all of this, jump back to the top. It'll come over here to position 8, and then we should be able to see it run from the top from here. So let's run this then as a run cycle so it gets through it, and sure enough it did do that. So let's see what's happened. Sometimes she runs a little screwy when you run it from the middle like this, just to make sure that it. So there's that center up position. Now it should move to position 11, which was 400 0. Yeah, that's good. Okay, go back to 9. Let's make some decisions. Bink. So position 3 is not greater than 3. So now it's got the new drop, which would be position 12, which is 350, 80. So there it's on the table now, runs through, and it should say, whoop, 4 is greater than 3. And how was my end not defined? Define label end. Okay, so jump to end. Oops. You know what I forgot to do? I didn't tell it to put an end out there. So I got to set that label. I created the jump to, but you'll see there's no word, there's no label that says end. So let's do that then, and let's put that right here. So it jumps to the end, create the label, end, and now it has a chance to jump to it. That'd be my fault. And there you have it. So it's a good idea to run your program for me before you shut it down. That way I know that your program is written correctly and that you've actually had it working for you. Sometimes children have a tendency not to participate and then just print somebody else's program and write their name on it without me actually watching how it works. So let's put this up to the top. I'm going to reset our Robocell here, cell setup. Let me move her around so that you can see what's going on. Let's zoom in a little bit. So there you have it. So let's take it from the top, put it right up to the top, and have everything get reset itself, and it will. By running through the set variable, it'll put it back to position 99 where we want it. We've already got 99 here. So then we'll create the home, pick, we'll go back to 1, drop will go back to 10, and then we should be able to run it continuously then until this statement here on line number 18 becomes true, where it'll end up as position 4, and position 4 is greater than 3, and position 4 is that red cylinder out there. That's the one way at the bottom. So that guy right there is our position 4. So it's 1, 2, 3, 4, and we don't want it to pick that up. So that's what we've set. So let's go ahead and run it from the top. Again, we're not running continuously. We've created the loop to be able to pick itself, so we don't really need to do that. Let's run that single cycle, and let's see what happens. Back to number 9. makes its decisions. So 3 is not greater than 3, so it's going to go grab the blue one. Set that one out there. Alright, so now it should say, whoop, I'm going to 4. No, 4 is greater than 3. Jumps to the end. And it puts itself away. Close grip. Ah, there it is. Got her done. Get her done. So that's robot number 10. Loops and remarks. Alright, so stay tuned for more of our series with the Intelitek robot. The ER4U robot.